organize it as you wish, the presentation, the introduction of the astronauts, and so on. Yeah. And the chair will be Kevin. So Kevin is our astronaut on duty today. He comes from TU Dublin, and he has joined the Human Mars team here in Holland. And we have here some spacecraft or spaceship Leiden Innovation Center, where we have the core team that is helping to run the show.
Make sure that everything goes okay.
Yeah.
Okay. Fine. Yeah.
Oh yes, and so I think we can start also to broadcast on YouTube.
So I have one request.
Yeah.
So Hank's trying to share a video, and in order to share a video, and in order for us to optimize for video clip, the host has to set it so only one person can share video at a time.
Yes.
You know where on.
Okay, so
that's it.
Share video or share content. So at the moment we have share multiple.
Yeah, so if you do it one person at a time, only one person can share at a time, which is actually an okay thing, and when he shows a video, it won't get choppy.
Okay, but this is not the host then. It's not the host if you say share one.
Oh yeah, now it's okay. Now it's good.
It's okay. It's so you guys fixed it, whatever it was.
You want to check? You want to check? So we are in the mode one participant at a time.
Okay. I will share screen.
Yes.
Oh, okay. Hang on. And then
yes.
Here we go. Share.
Yeah.
Okay.
Is there anybody that is following the YouTube channel? Yes.
Can you hear?
Whether on the YouTube channel we get the sound.
It's working?
Yeah, I mean, we can run it as a teaser before we start. Yeah, that's good. Excellent.
Yeah, that's where we start.
Yeah, okay, super.
So, gosh, where are we? Okay.
Oh, yes, so I wanted to...
Stop share. Oh, I see, okay.
The sound also goes. Okay, with the video. Okay, excellent. Okay.
Well, I should start with share screen anyway.
You could.
Okay. So,
I can't tell where what I'm sharing.
Go stop sharing.
Stop sharing.
That green box is what you're sharing. So go share screen.
Share screen. Yes.
And then you can leave it. Oh wait, trickle back. Sorry. You make sure we have the other boxes checked.
Yeah, they are.
Okay.
You mean these boxes?
Yeah. Okay.
Yeah. Share. And share. Interesting here.
and please advertise on all your channels that we are started. So I'm writing a message. Do you want to train as an astronaut? Join our Human Mars Astronautic Training Academy today. And we gave, okay, and I have to give the link. Okay. The link.
Where's the questions? I lost the questions.
It's on the email.
The question.
Hang on. Where's the email? Shit.
If I find them, I put them on the chat.
Hang on. No.
Okay. Countdown. So we are going to do the countdown, everybody in their native language. Countdown. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. And launch of the third day of the Human Mars Earth and Space Innovation Workshop that is taking place in a virtual hybrid format. So I'm Bernard Frank, and I'm the director of Human Mars. And we had 1 day on space data analysis and AI. On Tuesday, we had 1 day on instrument and space mission yesterday. And today, it's about astronauts and base, Moon Mars bases and simulations. And if you want to train as an astronaut, join us. Have all your friends and colleagues joining in, as this will be part of the training session organized by the Human Mars Astronautics Training Academy that we have just started this year. And as you know, some of you are now applying for either astronaut or for commercial Dear Moon astronaut. So what you are going to learn and practice today will make you better to be selected. So we have for the session today, our special guest training astronaut, Kevin McGrath. And in a tradition of this academy, we ask all the young professionals to take charge. So he will be the chairperson of today. So Kevin, the floor is yours. We don't hear you. Okay, so Hank is now from the International Moon Base Alliance. The floor is yours.
That's one small step for man, one giant leap for mankind.
Well, hello there. Good evening, everyone.
Aloha.
Can you hear me? Can you hear me?
Yes, aloha.
All right. My name is Hank Rogers. I am, my background is I'm from the computer game industry. You may know me as the guy who brought you Tetris. But what I'm going to become more famous for is the first moon base on the moon. And we start this with a facility we have called High Seas. I'm the owner of High Seas. I'm also the chairman of PICES, the Pacific International Space Center for Exploration Systems, and I'm the founder of the International Moon Base Alliance. Today, we're going to be talking to Commander Michaela Musilova and her crew of 5 aboard the habitat on Mauna Loa, the analog, called High Seas. High Seas stands for the Hawaii Space Exploration Simulation and Analog, or Analog and Simulation. And we have a crew of 5, and we are actually going to reach out to them in a little bit and actually talk to them while they are in sim. So they are on the moon and we are on Earth. But before we do that, let me show you a little bit about high seas. And sharing again, share. There we go. So high seas, first of all, we started with the design. When we first got involved, when I first got involved with high seas, it was because NASA and the University of Hawaii realized that neither of them could own a habitat. And they showed us their design, and basically they asked me to own it. And I said, if I'm going to own it, it isn't going to be a piece of junk. So my architect and I got together, and first of all, we redesigned it. We only had 4 months to build this whole thing. So at first, if you look at the original design, NASA gave us 1,000 square feet, which is probably 800 square meters. And we said, this is ridiculous. We need a little bit more space, because we insisted that each of the astronauts, the habinauts, the people who stay, the crew, have their own crew quarters. And this is, we believe that that the actual Mars mission, which was the design of the habitat was for the Mars mission. The Mars mission is 22 months. It's 8 months to go to Mars. It's 6 months to wait while Earth comes around. And then it's another 8 months to come back. So 6 people are asked to stay in a very small space for 22 months, okay? So inside the habitat, we have a work area, we have a kitchen area, we have a dining meeting area, and we have a wet lab. And then we go up the stairs to the second floor, and there are 6 little rooms, and they are as tiny as a room could possibly be. There are 2 bathrooms, one upstairs and one downstairs, and there is 1 toilet. And the mechanicals are in a 20-foot container, which contains the batteries and everything else. Wired magazine we sent them the design, and they actually did an article on us. So we were in Wired magazine. This is what it looks like, and you could see it in my background. We in the original mission we had a generator, but then we changed everything so that we have everything runs off solar. We even have solar hot water. So everything is now, there's no fossil fuel involved at all. The very first mission, we actually had flushing toilets, which was a big mistake. And then we got rid of them, and now we have composting toilets, which is more realistic. We have a mission control back at my laboratory at the ranch, from where we monitor everything. We monitor the water, the oxygen levels, the power situation. Everything is being monitored from down below. This is the interior of high seas, with crew working at their workstations. This is the kitchen area. By the way, we only had 3 months to build all this. So this is all, it's either IKEA or Costco or like whatever we could do in the shortest possible time. And these are the bedrooms. So each room is big enough so that you can walk in through a door and you can stand inside the room and you can change your clothes with privacy. So we have the opportunity to go outside the dome. Now, we did 5 missions for NASA, and the 5 missions were 4 months, 4 months, 8 months, 12 months, and 8 months. When you are in a Mars mission, basically the way it works is, first of all, if you go outside, you have to wear a spacesuit like this. And if you try to communicate with the outside world, we delay that signal by 20 minutes each way. So the basic condition is for whatever length of time that you're in the mission, in a Mars mission, you can only talk to the other crew members, not to anybody back on Earth. All the communication with Earth is through video mail or voicemail or email. So, and we are living on Mauna Loa. Mauna Loa is the biggest mountain in the world, and the material of Mauna Loa is it's iron. How can I say, iron oxide rich basalt, which is 96% the same as the moon and Mars. And so we even have lava tubes. And here you can see the picture of an astronaut and a cosmonaut, Oleg Artemyev, and our commander, Dr. Mikhaila Musilova, in an EVA, in a lava tube. This is an example of a lava tube. As you can see, lava tube is not easy to get in and out of. So I'm not a big fan of us living in lava tubes on the moon. They say they're much bigger, but I think we have better ways of doing this. So I'm going to unshare, stop share, and here we are. Yes, so 5 years of NASA missions, 5 different crews, and then those missions ended. And today we have pivoted, so we are doing moon missions. And the International Moon Base Alliance manages the moon missions, and that is Dr. Musilova's official job. So now we can actually switch and see if we can get everybody else online. How do we do this? Oh, you're already there.
We're over here, if you can see us.
All right, there you go. So, wow. Well, Earth to, let me just switch this over here. Hang on. There you go. Earth to high seas. How are you guys doing?
Wonderful. Hi, everyone. Aloha from the moon.
Yeah, so I'd like each of you to introduce yourself and tell us a little bit about yourself and what part of the mission you are managing.
Why don't we maybe take turns? Anyone want to go first?
Hi, everyone. My name is Cameron Crowell, and I'm an engineer at General Dynamics Mission Systems. I joined High Seas because I've had a lot of my friends do this analog mission or other similar ones, and I knew I just had to do it. What other questions were we?
What was your role in the crew?
Oh, my role is ISRU In Situ Resource Utilization Mission Specialist, and I'm looking at the soil and the lava surrounding the habitat and seeing how much iron content is in the soil there.
I have a question for you before you go away.
I'm back.
I'm back. So what do you hope to achieve during this mission?
So I hope to achieve a completed report on showing how it's possible to find resources out in the environment in an off-world situation. And so my research could be used as a means to plan for that type of resource gathering.
So you gathered, your plan in the future would be to gather materials on the moon and use them for something. What would you use them for?
Anything you need. If you can find something, you can extract it chemically. There's a lot of hydrogen on the moon. It could be used for rocket fuel or creating water or other chemical processes. So if you know what's out there and you know what it's made of, you can probably take advantage of it.
Thank you very much.
Thank you.
Hello,
Hi.
I am Monica Parks. My terrestrial career, I'm a vice president of information technology. I have a lot of experience in cybersecurity and fraud. And my role here is the science communications officer. So all of the posts that you see on social media are written by me. And I am also doing photography while I'm here, trying to capture anything and everything from a photojournalistic perspective.
So where on earth are you from?
I am from Tennessee in the United States, in the western part of Tennessee.
Is your family waiting for you to come back?
Absolutely, very eagerly. I have a 9-year-old at home who is chomping at the bit.
Wow.
Very excited.
It must be tough for you to be away for so long.
It's challenging to not be able to speak to them on the phone, but with us having access to email, it makes it sting just a little bit less.
Very good, very good. Thank you very much.
Thank you.
Hello, my name is Lori Waters. I am the Director of Communications for Magnitude IO and a co-investigator on the ExoLab 8 mission. I'm also a graduate student with the University of North Dakota Space Studies Department. So I'm the crew operations officer for this mission. I assist with the schedule and the daily mission report. So a lot of the logistics. And during this mission, I'm using a ground station of the ExoLab, growing clover, hoping to achieve root nodulation with rhizobia bacteria. And there's currently a flight experiment on the International Space Station happening now. So it's paired to the flight experiment. And so I'm studying food crop production for long duration missions as part of my graduate research. So this was the perfect way to tie together what I do with Magnitude as well as in my graduate studies.
Excellent, excellent. So let me ask you a question also. Tell us a little bit about the food that you're eating in high seas.
Well, astronauts typically eat dehydrated food, and while the space station uses a lot of pre-prepared food packets, we have quite a good number of crew members who make things from scratch. So we take these very basic ingredients, very limited resources, which is very realistic for what astronauts will have available to them. And we make delicious food out of them. We've had fresh baked bread. We had spaghetti tonight, chicken and rice bowls. And so we use these very raw ingredients and break out that old cookbook to come up with recipes from scratch. So we know that one thing that we're all missing, though, is that fresh produce. We were talking about how much we would love a salad or fruit. And we do grow some lettuce here in high seas in the lettuce grow system, but obviously it's got a very small production at this point. So maybe a greenhouse would be a good addition for some point in the future, as astronauts really need that nutrient dense foods, which is all sometimes hard to get in the prepackaged and the dehydrated food. So that's something that definitely is worthy of more investigation and study, is how to provide that range of nutrient dense food, calories, as well as make it realistic for space flight and time that it takes to prepare. So it's a very good analog for what surface crews would face.
Thank you very much.
Thank you.
Who's next?
Hello there. My name is Jack Bryan. I'm the crew engineer for our Saline 4 mission. My terrestrial job is as a systems engineer at Masset Space Systems, where I'm supporting the development of the EXO-1 lunar lander. So that's kind of the short and skinny of it. Aside from my duties as crew engineer, I'm also investigating in situ resource utilization. So I'll be looking specifically at combining habitat waste materials, such as plastics or metals, with locally harvested materials to make a composite building material that can be used for a variety of applications, including things like additional radiation shielding, or specifically for surface structures like landing pads or non-structural elements to protect equipment that doesn't need to be stored inside a habitat.
So what makes you want to go to the moon?
I think just an inherent sense of exploration. I think it's great to always be heading on to the next adventure. And I think that's part about what makes us human fundamentally, is that need to go one further and to see what's around the corner, not just because of the wealth of resources and knowledge that it is, but just for the sheer sense of excitement and it, that emblazons, I think, the kid in all of us to want to do something new because it's there and because we can.
Excellent. Excellent. Thank you very much.
Of course.
Who's next?
Hello, my name is Bill O'Hara. I'm a lead systems engineer with the Sierra Nevada Corporation in Colorado. So here during this mission at High Seas, I'm performing a case study of the habitat design. Part of my job at SNC is orbital and surface habitat development, and every habitat is different. And just like shopping for a house, every habitat has pros and cons in its design. And I'm here doing a case study of the High Seas habitat as one example of a viable habitat for the surface of the moon or Mars.
If it was your habitat, what would you improve about it?
It is a wonderful habitat, and I'll start there. It's been very roomy, plenty of space for us to live and do our activities here. I think the one area that I'm considering as a suggestion is a dedicated exercise space. We have exercise equipment, and it's in a couple different locations. So we kind of have to pull it out or place it in some of the equipment to use it. So if there was a dedicated area where it could stay deployed for the crew to use, that might be one improvement.
Got it. Very good. Thank you very much.
Yes, sir. Thank you.
You are also lucky you have a dedicated area for exercise outside. With all these activities, a lot of physical training. I had to follow Hank when he was commander of our precursor mission, and he was hard to follow from the physical side. So I think you have a great gym outside.
Except unfortunately, we've been having dust storms here on the moon that have confined us to the inside of the habitat for, what day is it today? 5 days. So fingers crossed we'll have a better weather in the coming days. And yeah, I just wanted to say hi. Hank kindly introduced me earlier. I'm the commander of this crew. My name is Michaela Musilova. On Earth and even here on the moon, my area of expertise is astrobiology, so looking for life in space. And in this lunar analog environment, I'm focusing on life that can live in lava tubes and trying to see if something similar could exist on the moon today, but Mars is actually a primary target where we're hoping to find these so-called extremophiles, extreme life forms. And we have multiple collaborations, including with NASA Goddard, Honeybee Robotics, and other organizations trying to understand how these extreme organisms live in lava tubes, how they move around, what exactly do they do in those lava tubes, and then how we could find something similar on Mars today.
So I have a question for you, Dr. Musilova. Why is space settlement so important?
Oh, wow. Well, a number of reasons. I think Jack earlier mentioned one of them. And so first of all, I find that space exploration unites people from different backgrounds, different countries all over the world. So many amazing projects like working on the International Space Station has been the work of multiple countries, people from different backgrounds working together, putting aside, their political, religious, and other differences to make this important work in space despite very difficult conditions. So I'm hoping that going to the moon and later to Mars will be a similar project that will unify different countries around the world to work together, and not just space agencies, but companies and other independent organizations. So it's a great way of bringing people together, bridging gaps, and kind of putting aside other differences. But also, settling on other planetary bodies is a bit of a fail-safe, a way to preserve humanity to some degree and not put all our so-called eggs in one basket on Earth in case something bad were to happen, like an asteroid impact, for example. And also we need to think about all the ways that space exploration has contributed to our everyday lives. So many space technologies, but even medicine and things like that are applied every day, and people's lives don't even know that it actually originated by first being prepared for space missions and for astronauts to exist in space. So I'm hopeful that with developing a lot of the in situ resource utilization technologies, like some of my colleagues talked about today, we'll develop ways to actually live more safely and in a more sustainable way on Earth as well.
So you yourself have been leading a number of missions now. How many missions has this been for you?
I'm approaching 30. I kind of lost track after a while. So, and I was trying to count how many EVAs I did the other day, and I think we're in the several hundreds, but I also lost track at this point.
Maybe you can tell us how you got involved in running the International Moon Base Alliance. I mean, how did you find us in the first place?
Oh wow, that story. Well, the short version is I actually was selected to be part of an 8-month mission here, one of the NASA missions that Hank was talking about earlier. Unfortunately, that mission didn't quite go according to plan. It ended earlier. But then Hank and I got talking about, what we could do here at High Seas instead, and to focus on lunar missions, since as Hank mentioned earlier, it's a big plan to build a moon base on the moon. And then one thing led to another, and we decided, well, why don't we start running these different types of missions and lunar missions at High Seas? And I decided to stay. Hank was kind enough to keep me here, and I've been running the mission since. It's been about 2.5 years or so.
I'd like to talk a little bit about the future of the International Moon Base Alliance. So basically, we're doing analog missions now, and that's very interesting. And the big pivot from the Mars missions to the moon missions was that in the Mars mission, they were comparing crews and crew selection. So they couldn't change the condition between missions. So everything had to be the same. So we couldn't improve the habitat. But now we're on moon missions, so we are free to do whatever we want. So we can improve the habitat as much as we want. We've been working on improving the suits for the EVAs, and I guess you guys haven't gone on an EVA yet, so you don't know about our suit. That's too bad, but you will. But the future is that our plan is to actually find a place nearby where High Seas is now, and actually build, have an area where we build moon-based prototypes. And I'm working to try to get 1,000 acres. And you can see it probably, if you looked in the picture behind me, it's somewhere down there, 1,000 acres in which we could probably build, I don't know, 10 different prototypes. And we're working together with NASA, NASA Ames, and we hope to build a lunar university with one campus at NASA Ames and another campus here on the Big Island where we can actually build things. Now, what you don't know is down there is a military base. And one of the things they do at the military base is live artillery practice. And so they blow things up. And the reason that I want to get the land from them is exactly because they blow things up. It means the building department doesn't get involved and tell you how to build something or how not to build something. They build little villages and then they bomb the villages and with artillery or planes or Marines and all that. That's only 40,000 acres out of 140,000 acres. And so I'm looking forward to have this to be a place where all spacefaring nations can get together and work together to build prototypes of a moon base, and then eventually go to the moon and build a moon base on the moon. So I welcome all of you, all of those who are interested in joining us with this effort to build the first moon base on the moon. We want to be there, have a permanent settlement on the moon by 2030. 2030, mark my words, we're in a hurry about this. SpaceX is going to get me 150 tons on the moon by 2024. That's half a moon base right there. So let's get busy. Thank you all for joining us. And thank you to the crew, and goodbye, and have a wonderful mission. And EVA, come on.
Yeah. Thank you so much, Hank. Thank you so much, the crew. Hawaii is an impressive place. Huh? It's a hotspot that just is connecting to the interior of the Earth. It's a very good analog for the moon. And what you are doing is an important step to help us to prepare to go to the next island in space. That is the moon. And where we conduct research, technology, in-situ resource utilization. We will develop business with services, also peaceful cooperation, and education and inspiration for a renaissance beyond the Earth. So, Hank, very impressive project. We have been honored to work with you and to collaborate on using the facilities, but also the human side of working together. So let's let's continue to the moon.
To the moon.
Thanks very much for everyone joining today, especially the team from High Seas. It was great to hear from you. And thanks, Hank, for showing us your habitat. We really do hope you'll be the first habitat on the moon by 2030. If there's anyone maybe in the chat or even in the room that would like to ask either Hank or the team a question.
So in November, we want to all come for a big workshop in Hawaii at the Blue Planet Ranch and using the ICs. So who wants to join? Yes. Excellent.
Okay.
Oh, okay.
I guess so. Next on the list is the chili. Adrian here.
Oh yes, yes. Before we leave, let's have a beautiful family picture with everybody, with our team. Yes.
They just left.
I took one. I took some. Yeah. Good.
Okay. Bye.
Okay.
Okay.
Oh yes, we know this is very early in the morning, on the moon.
It's
what time is it now? Your time?
It's 11:30 at night in Hawaii.
Hawaii.
I'm going to say goodbye.
So
aloha.
Next we have Annette and Sebastian, but I don't see them here.
Okay. Yes. So
they're from the High Seas Mission 1.
Yeah. So yes, Annelot. Sorry, I have to unmute. Yeah. Annelot made a presentation yesterday that we have heard on the result of our analysis, and together with Sebastian, they have recorded in fact a joint contribution.
Okay.
And so I think we will pass that during the break. A presentation that has been on at COSPA.
Okay.
So yes.
The next crew, unfortunately, I don't see them here either. We have Sabrina from High Seas 2, then Mark and Roberto from High Seas 3. Would you like to share your screen?
So I may do. Yeah. I can do some.
Say, Roberto.
Yep.
Would you like to share your screen?
Well, honestly, I don't have the presentation of slides.
No,
so
yeah, it's for the. So okay, I will cover that then. Okay, so so yeah, so I have a series of overview of what we have done with the ICES mission, and then we can go on me. And so yes, so let me share. what we have prepared together. Yeah. So, okay, do you see my screen?
Yes, we do.
Okay, so here is an overview of what you hear me. That's good. Yeah, an overview of what we have done at the International Moon Base Alliance. As you have seen, so they have conducted the okay. So I'm not mute. Yeah, now, yeah, I'm on. I'm on. Okay, good, excellent. Yes. So, as Hank mentioned, so we have started, actually, he started this initiative of International Moon Base Alliance, where we had in 2017 a large event community conference that he hosted in Hawaii. And then we released this International Moon Base Alliance with a number of participants and institutions, including NASA, ESA, some space industries, and some various groups developing our roadmap towards the moon base. And also at that time, we sought to reconvert the ICES facilities that Hank and his team had managed, and where they were conducting long duration mission for NASA, so up to 1 year mission, and to use them to make specific training for a lunar mission. So this is these facilities, and in particular, yesterday we had a talk from Christian Heinecke. She was one of these astronauts that spent 1 year on Mars. She was confined in this ICES base for 1 year, and she also performed a number of exploration activities in lava tubes, in the landscape. At that time, also she used the laboratory, so the wet laboratory, to perform some geology and astrobiology experiments. And as a follow-up of that, Christian has been developing even a more sophisticated and realistic base with a number of modules, that would allow redundancy, and she has built that in Zaram in Bremen. So at the time in 2017, we decided to launch a series of missions of lunar conditions, and that's when I went with Hank, and created a kind of technology precursor crew, where we had installed some new equipment in the base, ICES base. And so we created a crew, also bringing some EV equipment. We also developed a special vehicle that would go into lava tubes. I brought a drone, and we brought also some equipment to analyze samples, so like microscope and a spectrometer that we have here. And so we spent a short campaign to validate some of the technology system that we would want to use. So after this, we decided to go to the next phase, which is to really have a full-fledged mission simulation, where also at Blue Planet energy range at some 20 kilometers distance from the base itself, we had a mission control setup. And so there we have the help of Paul, so the Vincent Paul Pontius, so the engineer that designed the habitat. And we have installed this facility. So for my second visit in
So, okay. Okay. Sorry, we had an internet problem, so everything froze.
There's a solar storm that has affected our communication from the moon. We are just go.
Do you want to turn the camera on?
Oh yeah, so that's another thing. Okay. In the meantime, we are resetting the system, and so I will then give a kind of overview of what we have done, and then later we'll, when we have enough bandwidth, that we can also transmit some images. After the solar storm, we will show them. That's also a situation that will occur from time to time when we are on the moon. And when we are doing the training of astronauts, I'm recommending everybody to also train how to use the minimum amount of bandwidth and data. So for instance, when we do our simulation, also in particular when we do the simulation in a Mars mode where you cannot have any real-time communication, I can remove that because now I am in a safe sitting position. We use a lot of text communication. So for when we do our simulation, we do for the daily briefing in the evening where we analyze some of the data that is sent by the astronaut, and we can give them some text feedback. We also have some pre-planning of some of the activities. So we do that in advance. So we have a midterm plan where we plan what are the overall objectives and what type of activities we would like to conduct overall. And then we start to make a daily plan in advance. But this is then revisited one day before to see as a function of what we have obtained as a result, what would you like to have for the next day. And then we give some autonomy to the crew. And actually, we also apply principles that in the future, we are not going to have a space mission where we are going to script everything that the astronauts are doing. So that's a principle that actually we have acquired, even from the Apollo time. They were not scripted, and it's based on the principle of T3. What does T3 mean? For the astronauts, you need to train them, to trust them, and then turn them loose, which means that they will be trained enough in advance to handle the problem so that you don't have to really control them, be on their shoulder. They will have all the autonomy to take the decision by themselves. And so that's also what we are planning in our astronautics training academy to train the astronaut in a way that they will have sufficient knowledge, experience, practice, so that really they will be the best person to operate. And then in a remote, we have the ability to support them, for instance, to prepare some scientific investigation and so on. Okay, so yeah.
So I guess next would be Adrian, if you would, from the Ojos de Salado Chile Moon Mars team, if you would like to share your screen.
Wait.
Adrian?
Yeah, I will, you can hear me? So I will share. You can see my screen?
Yep, perfect.
And you can see the whole screen, or you just see, in fact, the slide in
in LibreOffice.
We can see the slide perfect.
Okay, perfect. So, okay, so hello everybody. So I will speak about the start, about the Chili Moon Mars component of the Our Moon Mars program, which start in fact at the beginning of this year. And the first step was the Oros del Salado campaign, which was done from the 22 of February to the 3rd of March. So it is mainly done inside the LICA laboratory, even also the CRIDESAT, which also involved. So the LICA is the Cryosphere and Water Research Laboratory, and CRIDESAT is a laboratory which is specialized in microbiology. And also for this Oros del Salado campaign, which was really positive, the TU Dublin students were involved to make the remote support. So here in the background, you have some picture from the Atacama regions. So it's not really the Atacama Desert because we are in the Cordillera. And so you can see this kind of print of a wheel. It's not the Perseverance wheel because we are in the Earth. But if we make some adjustments, yeah, we can go on Mars. So the first step is to understand a little bit why the Punya de Atacama is a good analog. It could be a Martian world. So the Punya de Atacama is an ecoregion, so which is located in South America between Bolivia, Chile, and Argentina. So normally the mean altitude of this ecoregion will be between 3,500 meters and 4,500 meters. So here you have a very interesting graph, which is in fact the classification of the morphogenetic region. So you have here the mean annual precipitations versus the mean annual temperature. So you can have an idea of the climate. It could be roughly the climatic regions. So in this graphic, you have in orange the Atacama region, and in blue the Punya regions. Okay, so the Punya de Atacama region will be only a part here of the Punya. And you can see the different points here, which are point of climatic reanalysis. So for the blue, it will be the Punya, and for the orange, it will be the Atacama regions. You have also some points in green and in red. So in red, for example, 30, 50, 60, they are related to the actual condition you can have on Mars at different latitude, and the number in fact represents the latitude. P10 is the condition Mars may have experienced in the past. So it will be related to an atmosphere of 1,000 millibars, so very close to the one we have on Earth now. So it's 100 times the pressure we have now at the surface. And P3 will be the condition with 300 millibars. So some atmospheric pressure Mars may have experienced in the past. And in green, V is related to Vostok. So the condition we have here in the center of the Antarctica, in the recent stations. And LGM is the last glacial maximum, which corresponds approximately to 20,000 years before the presence. And you can see that in fact the best analog now on Earth, according to the climatic in fact condition and according to this morphogenic classification, will be the Antarctica. Then we can think that the Punya de Atacama region is also very good analogs. You can see, for example, especially the region of Atacama, because we will be in this part of arid, semi-arid, and periglacial, in fact, morphogenetic regions. So it's only for these two parameters of precipitation and temperature. Of course, there is also other parameters which will be important. And one is the altitude, the different gradients you can have, in fact, in this region. From, we'll see the sea, and you will have the Atacama Desert, in fact, close to the coast, and to the peak above 6,000 meters we can have, in fact, in the region. Okay, so this was for the context. So the University of Atacama is the only university, in fact, in the region of Atacama in Chile. So you have 7,000 students and different faculties. And we are working here in the LICA, in the faculties of science, in the EdicTech. So the background of the LICA is mainly focused on geophysics and geochemistry, so the analysis of cryosphere, ice, and water. The main focus is a link with the water, because it's a scarce resource for the regions, and it has a lot of impact for the economic development of the regions. But we try to develop also the remote sensing. For example, personally, I am working mainly with satellite images and numerical modeling. So this is the background. There is, for years, an accumulation of data, so mainly of geophysical analysis, but there is a lack of analysis and a lack of valorization, scientific valorization. So the aim will be, in fact, to try to valorize this kind of gold mine, for example, to involve students in a PhD or master project, because we need to use, in fact, this data. And there is also a possibility to valorize in the field of planetary science. Due to the context I explained just before, or the Martian context, we can say, we can use this data in a planetary context. You have just, in fact, to change a little bit the framework, because we are now, the LICA is working mainly on environmental issue, but we can change the framework, in fact, to work on planetary science. And it's also a will of the university to develop this planetary science component. So to do this, so it's mainly the framework which can both do, in fact, environmental science and also planetary science. Here you have the exploration laboratory, which was a project developed 2 years ago in order, in fact, to do some field work in the Cordillera, because it's very remote. So you have access, quite easily access if you have all-terrain vehicles, but you need to be independent. For example, you don't have access to fresh water and so on. So to have these kind of facilities and to make exploration also, because the region is not so well known, there is lots of things to do, notably at the border between Argentina and Chile, and also in the northern part of the region. It's really interesting to have these kind of facilities. There is also a project of a high altitude laboratory, because, for example, to store the sample for the acclimatizations, it is very interesting to have this kind of facilities to facilitate the work in high altitude, which could be quite complicated and quite demanding. So the objective of the high altitude laboratory, of course, is to focus on high mountains ecosystems. But there is project in astronomy, health, adaptation to high altitude, microbiology, geology, and also planetary science, which is really normally an issue the university wants to develop. A small graphics, in fact, to explain the strategy of the Atacama High Altitude Laboratory. So there will be a first exploration part. Normally it will start this year. The construction will be finished normally in the following months. We will have some meeting in the following days. So this exploration part from 2021 to 2023. So with the construction of the first base camp which is called site alpha at 3,800 meters. So this is plan. Then a kind of exploration part during 18 months in order to find a new site to do science and to install another laboratory above 5,000 meters. The plan is to install it above 5,200 meters because the university wants to have the highest laboratory in the world. So, but this has to be seen according, in fact, to the scientific goals and also to some logistic constraints. Okay, so now let's speak about Chile Moon Mars. So you can see that there is a kind of willing to develop the planetary science, and so it was important to have some competence to develop this planetary science. To have a collaboration with our Moon Mars, it was quite logical according to the different activities. In fact, our Moon Mars is doing also according to the experience with the different campaigns which has been organized in the past. So we are thinking here that the mid-long-term objective could be the installation of an analog module above 5,000 meters in order to organize kind of analog campaigns in this module in high altitude. So according to the characteristic of the region, but also according to the objectives we want to develop. We need to have a main objective, and we are thinking here in the team of the geoscience team, which wants to develop this kind of activities, as it could be a very good objective, technically, logistically, but also to have all the scientific objectives, the first scientific objective, which will be to determine the potential of the region in terms of analog, because there is not so much work on this. There is works on the Atacama Desert, in the Cordillera, but more in the north, close to the Salar de Atacama. In the Atacama region, there is not so much work. So here you have the picture on the left of the laboratory, which will be built at 3,800 meters, and on the right, the IC module, because we are thinking here in the LICA, also in the predecessors, that all the experience there is in the IC module could be very interesting to implement a module above 5,200 meters. Okay, so some projects which are ongoing for the Chile Moon Mars or Euromoon Mars and Atacama. So there is the potential of the region as a Martian analog, which is the main objective we have to develop in the following months, following years. There is also a small program which is linked, in fact, to the logistical activities according to the field work we can do in a space exploration context, which is an aerial platform. I will speak also a little bit about the human adaptation to harsh environment and what we do next. So quite quickly, so this is work which has been in fact presented, which are currently presented in the Lunar and Planetary Conference. So here the Euromoon Mars project. What will be the aim? But the first aim will do a kind of remote characteristic, even if we want to do also some fieldwork, and to contextualize and to have and to define the potential of the region as a Martian analog. So we have a plan, and we are starting, in fact, this study to use different remote sensing data and to compare them, in fact, to the equivalent we will have on Mars. So it will be to use visible and near-infrared with high and moderate resolution, to use hyperspectral data to do a kind of mineralogical characterization, and to use also the digital elevation model to do a characteristic of the geomorphological landform we can find, and lots of geomorphological landform you can find in the region are quite similar to the one we can see on Mars, which is quite interesting. We have the possibility also to use some data which have been collecting, in fact, by the Cerna Geonim, which is a structure in Chile which is in charge of the research, kind of research they are doing They are collecting all the data which has been done for the mining prospect. And there is very interesting data for the characteristic of the region as a planetary analogs. There is a potential to use some data of spectrometry, for example, at high resolution. Okay, this is a ExoKite project, so it's more technical and engineering project. The aim is to use a kite as an aerial support tool, so to help the fieldwork with directly transmission of video, position, and to facilitate the communication with the radio relay. So for example, here you have first simulation with radio relay. For example, if we use an ExoKite, or here it's in the region of the Ojos del Salado, it was to do some tests with Longley Rice propagation modeling. So if you use, of course, an ExoKite with a radio relay even of 5 watts at some 100 meters of altitude, of course, you will have a better coverage. So we start some simulation to see if it was relevant, which kind of surface, for example, we will need to use a kite on Mars. So it was just modeling, but the aim is really to use a kite in the Cordillera because you have lots of wind at specific slot periods to develop technically, in fact, this platform. It was quite interesting, you see, because you can see this illustration which has been done, in fact, for this project. It was done by Anna. So there was a kind of connection also with Artmont Mars, and I think it will be interesting also for this kind of project to try to have this kind of illustration, which are artistic illustration, and it could be also a link with a different compound in the Artmont Mars project. The adaptation to high altitude, because we are in high altitude, we are in hypobaric and hypoxic conditions, so there is also a kind of research which can be done on this aspect. Now we speak a little bit of this with the Ojos del Salado campaign. So the Ojos del Salado campaign. So you have here, in fact, the in 3 dimension the playground we use a lot. In fact, so here you have the Salar de Maricunga, the Ojos del Salado is here. So it was a campaign which has been done from the 22nd of February to the 3rd of March. And we start here, okay? So we have a kind of altitudinal gradient. Here you are around 3,800 meters. Then here you are close to 5,000 meters. The Laguna Verde, you are around 5,300 meters. Here, 5,000. And here you are above 6,000 meters. The main objective was to change some temperature sensor in the Ojos del Salado altitudinal gradient here. But we need acclimatation for this. So we need to spend time before at lower altitude before to go there. So it was possible for us to implement some new protocols. So we developed quite quickly. I think it was a first start, and we have to improve all the protocols. So we make lots of samples of water, of soil, permafrost, biological crust, salty crust, and so on. So we'll make some biological analysis and also geochemical analysis to define the environment at different altitudinal gradient. So we make also geophysical work here because it's an area of permafrost. But in the future, in fact, when we have this kind of campaign, it could be planetary science campaign, of course, but even if it is for environmental campaigns, due to the fact that we need acclimatation, in fact, we will be happy, in fact, to implement new protocols which is not related directly to our research, but for example, for the team, not only for the university, but also for the institute to accumulate data. Okay, so the Ojos del Salado campaign was also the opportunity to work with a TU Dublin student. So here you have some picture of the field, but we have a remote support from the TU Dublin team. So here, for example, with Shirayu, we tried to develop a close-up protocols. So you have some picture here with this dot, in fact, to do the color calibration. So it was very complicated on the field because we have very windy conditions, so it was quite complicated to implement the protocols. So here I spoke a little bit. It was some discussion with Gary about the radio communication simulation, which will be interesting, in fact, to translate to Mars, because we can use a digital elevation model to do the same simulation on Mars. The sample with Anna, and Anna also helped for the communication, because every day we have a weather forecast, which was done by Kevin and Anna. And also Kevin work on the physiological change we can have in altitude with an adaptation of the MOCA questionnaire, which is normally a questionnaire which is used to do a diagnostic for the person who can have Alzheimer, for example. So you have some question which can, with a score at the end, with a rank, which can define, in fact, the decrease of the cognitive capacities. And we have not to forget Bernard, of course, because if I can be involved personally, and also for the LICA, we can be involved, in fact, in the Roman Mars program. It's thanks to the activism of Bernard, in fact. We push us, in fact, also to participate to some congress. So it's really dynamic, and for us, it's really positive. So what else? Next, we want to develop a common campaign. We'll speak about it in December or at the beginning of next year. So we will be interested to work with students. So we'll work with one student of the Vrije University of Amsterdam with remote sensing data. But it will be interesting also to have interaction, in fact, to develop logistically, technically, scientifically, or to characterize the potential of the region. So it will be interesting if some students want to join us to work on data or the organization of the campaigns. For example, to give you an idea, to organize a campaign like the one we made in the Oros del Salado, which is a 10 days campaign, it's approximately 1 month of work to prepare logistically and technically this kind of campaigns. Okay, what next? So we'll have a campaign of ice drilling in the El Potro Glacier in April. So it will be only a LICA expedition. But there is a question if we do again a remote support or if we can implement new protocol because we will have the same problematics of acclimatization, even if it is at lower altitude, because the base of the glacier is at 5,500 meters and the higher part is close to 5,700 meters. The main objective is the Chile Moon Mars Scout campaigns, so which will be organized at the end of 2021 or the beginning of 2022. Now we have some problematics of astrobiology, geophysics, logistic, adaptation to high altitude, but we are open, according to the person who will come, to add some new protocols. We have to see this. So it will be a 15 days campaigns, but we stay 10 days in high altitude. So because we have, of course, to respect the acclimatization process. One main objective will be also a reduction of funding proposal for the analog module project, but more generally also to get some fundings, because the objective will be also to help the person who will come, because of course there is a cost to organize this expedition. Also there is a cost to come in Chile from Europe. One marketing video, which are some images taken from the campaign, because we cannot speak really now about science, so we can make some advertising about what we are doing. So the last mountain you have seen, it was Lloros del Salado. So the highest mountains in Chile, the highest active volcano on the Earth, and it's the second summit of South America. So there is a high potential, in fact, to develop planetary science under this thematic of Martian analogs in the regions. So of course, this is the Room on Mars project, but it's also important to develop this here locally with a Chilean partner, of course, because here we are in Chile, but there is also potential, high potential to have a collaboration with Argentina, because there is all this part of the Catamarca region, which is on the other part of the border, which is less unknown than the Chilean part. And there is also potential in the Bolivia part, but it's much more, it's quite far away here from the Atacama region. So if we focus for the Atacama region, the potential is to do so, of course, the collaboration with the Room on Mars project, but also I think with the Argentinian part, it will be quite interesting to go to reach the Argentinian border and to see what there is in the Catamarca region. We make some field work. There is, for example, very huge field dunes, which are quite interesting in terms of geomorphological landscape. So thank you very much. If you have some question.
Thanks very much, Adrian, for showing us all the work that you've done. It sounds like it's a very interesting campaign. And I guess also to say on behalf of the Dublin team, thanks very much for including us as part of the remote support. We definitely we learned a lot. Is there any questions maybe from someone on the Zoom or in the room that would like to ask Adrian a question? Yeah. Okay, yeah, I guess. Again, thanks very much. And yeah, like Adrian was saying, the Dublin team, so there's myself, Hannah, Gary, and Shiryu. It was the first campaign we were involved in as part of our internship. So we got to act as the remote support. So that involved twice a day sitting down. So in the morning, we would send a weather forecast. And then in the evening, we would send another one and sit down to actually converse with the team in the field and hopefully fix if there was any problems. Luckily, nothing came of that, so there was no major problems. But yeah, so I actually might be able to show you some of the work that we got to do. Second. Okay. So for anyone that's looking, this is what the remote support entailed. So I mainly looked at the protocol, everything involved with working with teams. So our basic protocol, one of the first things we learned was actually using the codes, as you can see. So different codes express different types of messages that were sent throughout the day. So for example, the M11 was the first forecast of the day for the first day of the campaign. And yeah, so we had to use, I guess, a system to actually give a weather forecast that was within 140 characters, because we were using SpotX, which was a communication device that, how do I explain it, was I guess able to reach the team in the field, because without cell coverage you couldn't do it. So yeah, we were able to do that for the whole of the campaign, which is great for all of us. So we definitely learned a lot. And again, thanks very much to Adrian for including us.
Well, thank you to participate, because I think it was a huge effort also to participate to the different meetings for the elaboration of the protocols. So no, for us, really appreciate in fact that you can participate, and for us it was helpful. So mainly we did a kind of debriefing for this. It was mainly for us for the weather forecast, because we need the forecast of the wind, for example, to do the different drone flights you have seen in the video. For us, we need the forecast of the wind. For many, it will be approximately the same. In fact, during the day, the wind will start around midday till the end of the afternoon. But the forecast, in fact, you sent, for example, it was really useful for work we did to get a digital elevation model for some Yardang, which is a geological landform you can see also on Mars. So this is a kind of Yardang which are quite special here in this permafrost region because they are not consolidated. So it's quite it's a mix between a dune and a Yardang. But we did the work to get the digital elevation modeling, and so we had the weather forecast, and we stopped, in fact, the processing, or everything was finished, and the wind started to blow. I think, yeah, with quite high velocity, so it was perfect, in fact. And it was planned before due with the weather forecast, so it was really interesting for us. So thanks.
Excellent. So I see that I wanted to say that we really appreciate the way you have been working and organizing these Chile Moon Mars initiatives, and so also from the research-driven aspect, I think it's very important to have this because it gives a strong dimension and very realistic of what we will want to do on the Moon and Mars. So I have some practical questions. So you are mentioning a LICA new campaign in April. Do we have the dates already about? There could be a possibility that we could support it as well from our side. So our astronauts from Dublin, they will be at the end from 22nd of April. They will be on the moon base in Poland, but they will do mission support. They could also do mission support from there. And then the second question, yes, you mentioned a possibility of a scouting campaign that we could try to organize with a small group. And then the big campaign in the end of December or January that we are going to work to organize this crew spending Christmas or New Year in Chile. I've done that in the past. I was astronomers and it's a great experience. So I'm looking forward, and this might be also a way to get more people available to come, over this period. So LICA, April. So what are the dates at the moment?
We don't have dates.
Okay.
So in terms of interest for support, it's a little bit less interesting than the Oros del Salado campaign because the objective is to be quite quickly on the glacier, and then we will do. We need to do, in fact, the drilling on the glacier. So there is will not be a kind of scouting campaigns because we will do some geophysical works at the beginning, and then we will be on the glacier.
Okay,
no,
so
there is no plan. Yeah, there is no planification, yet, because in fact we are quite flexible. We will wait to see the evolution of the situation. Again, we have due to the pandemic here, it's worse here in the Atacama, and we need to wait. In fact, because we did the first campaigns during the summer holidays, and now the university start again. And so we need to wait a little bit, in fact, to organize the campaigns due to administrative procedure because they start again with the subscription of the different students. So it will be in April because then it will be a little bit late in the season because we will start the winter after. So we'll have we can have bad condition, and it's the south. It's in the southern part compared to the first campaign we did. So we know that there we can have more precipitation, for example. So we have to do it quite quickly. It will be in April. We don't have yet, in fact.
Okay, we will see, but we can organize some support as needed from our Empol base. They will be full time doing mission support. Then also what I want to mention that I saw that Chile now is in the world record in terms of percentage of vaccination. So I think that there are some, so the situation will be safer and safer there. And so, we are looking forward, yes, this campaign, end of December or January. And this will be one of our big effort. We like also the vision that you have integrated with the discussion with Hank Rogers and to have an ICs type of facility. It would fit very well there, and in particular for Mars simulation, Atacama is a very great analog.
But yeah, we really think for us, it's really the main, it will be for us a good idea, for example, to aggregate, in fact, some scientific issue, for example, to try to have this kind of thinking about landing site and to have this kind of landing site, which will be, in fact, integrated to this objective of the module. And for Chile, it's really innovative. So we think that we can get, not easily, but we have, of course, we have to redact the project, but we can get fundings for this, which is regional fundings, because there is some regional fundings with the Atacama region, or even national fundings with the Fundicit. And we have, so there is some discussion with this, the person who is leading this project of the iLaboratory, and he's really supporting us, the LICA mainly, because he sees the potential, in fact, to develop this kind of things. So we have a support here, and so we really want to develop this, and we hope to get fundings, for example, to help the students who will potentially come for the different campaigns.
So amazing. So I propose that now I will show some of this EMMESI slide, but also an overview of, I love also your quote from Clooney, what else, what's next, and to give a big picture of what really, why we started this exercise. So I'm going to show you the history, in fact, of Moon Mars, but from the point of view of human spaceflight. And we have we have discussed on Tuesday how we started, in fact, by focusing on data analysis. It was at the time of Mars Express and Smart One, and then we moved into instrument development for the next landers. But today we are going to talk about astronaut, Moon and Mars bases and simulation. And so this is our vision for the Moon, sustainable presence on the Moon base at some stage. And there are a number of challenges that we need to solve. So with the rocket industry, okay, we need to get there safely. But after we are there, we have to ensure that we have all the tools and the protocols and experience in communicating, in operations, in surviving in extreme environment, in mobility, in order to explore the areas with robots, but also with humans. And this partnership between human and robots, so that will make the base much more efficient also for research. And, in the time scale of 2030, when we want to be permanently there, the use of resources and the involvement of a large community of partners and collaborators. So some little bit of history. So after our robotic phase that we had discussed yesterday with our ExoGeoLab lander that we built in 2009, we also developed some habitat facilities. So this is the so-called ExoHub. So it's in fact a repurposed caravan for 6 that was transformed into a Moon habitat for 4, where you have here some team from SuperHero that are doing testing communication, remote control of rovers and telescope, analysis of samples, 3D printing, and other facilities. And then we started actually already in 2009 a series of Mars mission in the Mars Desert Research Station. At that time, we wanted to validate some research for supporting Mars Express, but also for preparing for the interpretation of Mars exploration rovers and the Mars Curiosity. We also conducted some field campaign in a volcanic area near the Netherlands that's called Eiffel, where we did some also test of the partnership between astronauts, a bit like we did yesterday, astronauts, landers, and 2 rovers. But also we had some sample analysis tools on the rovers and also with a laboratory to analyze this volcanic sample. In ESTEC, we also had developed one module, which we call ExoLab, which is a laboratory module for performing biology analysis or astrobiology or planetary protection protocol. And so this is the campaign that we performed in the Mars Desert Research Station. So we started in 2009, really addressing research, laboratory research. We had facilities, field research, demonstrating instruments. So this we discussed yesterday, but also looking at habitat technologies and also operations with a human aspect. And clearly, something which is important is how we use this expedition as a way to train young and advanced professionals, and also as a way to communicate so our passion and our experience into space. So here, just for the Martian, yes, we are also looking at the analogy between Mars, you can see on the top, and the Earth. So for instance, you have some ancient salt deposit a bit okay, we have also that in Atacama, in some of the Salar, a different history, but there are also some common points, and that helps us to understand Mars, but also looking at astrobiology, looking at extreme of life in this environment. So developed by NASA. Here we work directly with the principal investigator of the CheMin instrument that is on the Mars Curiosity. And then we performed also some campaign in ice, in habitat. And this was a campaign with the Igluna team in 2019, where we built an habitat in ice and we brought a lander and we performed a number of investigations. So also at the same time, we developed a series of expeditions toward Iceland, and Mark Emskerk has joined us, and we discussed with Charlotte and with Sabrina and with Sheila's team what are the next steps, what else, yes, for Iceland. But we did some precursor campaign there, looking at lava tubes, and we had also developed some activities in Poland. We started in 2016, and then we had a full-fledged campaign in July, August 2017 in Poland, also with the Space Generation Advisory Council, and a number of campaigns were conducted there. We even brought our lander there in this lunar rest facility. We isolated our team of young, enthusiast astronauts for 2 weeks, you know, all smile, very passionate. And that was the picture before. We locked them down for 2 weeks. In the meantime, we fed them with hydroponics, and they could take care of the plant, very good for psychology balance. And so I have mentioned what we have done then from 2017, using the ICES facility, mission control I described here. Then we started from 2019 to have a series of Euromoon Mars International Moon Base Alliance ICES campaign, so-called EMMESI. This was EMMESI 1. Here the view from the moon base from the drone, and you can see, and that's something that you will want to adapt also for Atacama site. We can provide you here a view of day 3 when we had to repair an antenna as a preparation for astronaut for EVA sortie supported by the mission control. And field traverse where we had some team members exploring the volcanic basalt like we would do on the moon, and then coming back to the base to eat space food prepared by a special cook. Here to geology students that did their master research using the analysis of the sample. So that was Anne Lotte and Sebastian, and they have been doing a very beautiful also post-analysis sample work that led to their research master. So here they discovered an entrance to lava tube, and so we had used the opportunity also to visit them with the cosmonaut commander, so Oleg Artemyev on the right, and the inventor of Tetris, and Hank Rogers, while they were in the crew. So in the big picture of things, this is how we want to use our Your Moon Mars work to test some elements for robotics and instruments. We have discussed that yesterday, but also prepare also the design and the definition, the operation of what will be these human-based facilities, the hardware part, the infrastructure, but also the human factor, the human aspect. And so there is also another humanity aspect that we are going to look at tomorrow with a special Art Moon Mars and Space and Society event. But so you see, all this is very much connected. So that's an overview I wanted to give on how our Your Moon Mars activities have expanded to include a lot of Earth-oriented activities, both in making our simulation campaign in extreme of Earth that look like the Moon and Mars, but also even to develop some tools for the analysis of Earth's remote sensing data. And you have mentioned that, Adrien, you are going to use some of this advanced data from Earth, also to address some scientific questions which are very important for us, like climate change, glacier evolution. And so some of the tools we have developed with planets in mind, we apply them to Earth, but also we will learn from Earth to better prepare what we do on the Moon and on Mars. So that's an overview of what we want to develop in terms of Your Moon Mars next steps. So we have worked a lot with the US, with Mars Desert Research Station, with Hawaii. We are trying to develop also some facilities in Europe, like we have in Poland, or we had field campaign that we can access from here, from the Netherlands. We are looking at a facility which is on 2 continents at the same time. That will be in Iceland. You know, they are on the 2 plates. You can walk on each, on the American and on the European plate. We are developing this Chile Moon Mars, so South America, a very important continent. And even in the future, okay, next year, we are looking at developing further some activity with Asian Moon Mars, with Korea in particular. We have heard yesterday TASIC, and we had even some been approached for an initiative Africa Moon Mars with Space Generation Advisory Council Africa. So clearly, we want to use some of our experience of the last 12 years with Your Moon Mars to help also other groups to develop a planetary and Earth exploration platform that will be also used to train young professionals to analyze data, to develop instruments, to go in the field, to become Earth astronauts before we can be astronauts beyond Earth. So that's the vision. I want really to congratulate you, Adrien, and your team in Atacama for what you have done from the research and also how you have integrated our team here, the Dublin team. So thanks all of you. So I give back the floor to our chair, Kevin, now.
Thank you very much, Bernard, for showing us all the great work to do on the high seas. I guess next on our schedule is the Chill Ice team. So we have Mark Hemskirk here, who I think has a small presentation for us. Thanks for joining us.
Hi, I hope you can hear me.
Yes. Yes, we do.
Let me quickly share my screen. So I'm actually right now at Schiphol. So there might sometimes be some noise from the trains behind me. I hope you can still understand me. So today I will present a little bit about Chill Ice, which is the newest analog mission. Chill Ice is an acronym because we love our acronyms, and it stands for the construction of a habitat inside a lunar analog lava tube. So to introduce myself as well a little bit, I'm Mark Heemskerk. I'm an exogeologist from the Free University in Amsterdam. After a very elaborate bachelor of science in physical geography, in geology, and in geochemistry, I also was part of the EMMESI missions as a lead scientist. And being a geologist, of course, I like to walk on rocks, I like to scratch myself on rocks, and I also like to get myself stuck on rocks. And later on, I also was a part of the first ISP pilot program of the International Space University, Team Mars, go Team Mars. So for the Chill Ice core mission team, we have 3 heads. The first one, of course, is me. I'm in charge of all the subsurface operations, so it will be, of course, a large part will be subsurface of the whole analog mission, but also of the research campaign surrounding the missions. And we have Charlotte Powells, she's our head of logistics, and she's also working mainly like in an overview way. And Sabrina Kerber is our communications officer, but she's also our space architect. So she's a lot in contact with the KPU who are designing our habitat. And of course, you can always reach out to us at info@chillice or to me personally at mark@chillice.com. But these are not the only core mission team members. We actually have quite a lot of them. I think this is the most recent list of all the core mission team members. But we also have a lot of support as well, coming from other members as well in financial, logistics, instrumentation, and equipment. And of course, this is a project of Euromon Mars, just this workshop. Sorry, wait for a little bit for the train to pass. Yes. Okay, I think that was the train to Leeuwarden. Glad I'm not there. So, yes, of course, Euromon Mars, and I think Bernard and I have been working on keeping life alive for a large part of our lifetimes already, focusing on different types of habitats and also analog habitats, including, of course, the high seas habitat, but also some other projects, which I think we have already heard a lot about, working towards Lunar Village, as Bernard already very nicely worded just now. But the only problem if we are looking in a lunar village and having humans stay on the lunar surface for a longer period of time is the protection. So we need protection from meteorites or micrometeorites, just like dinosaurs, otherwise we will die out. But we also have a lot of solar activity and no atmosphere to protect us from it, no magnetosphere. We also have a lot of regolith on the lunar surface, and this regolith is a very, very fine dust, which is also very harmful for the human body. And there's a problem of thermal insulation because at the lunar equator you have a diurnal variance of almost up to 350 degrees Celsius, which can also tire or wear out any of your constructions or alloys. But on the same hand, we have the problem of costs. So you may want to have a very thick wall and very thick layers of protection, but currently it's almost 1 to 1.5 million euros per kilogram that you want to send safely to the lunar surface, which of course is a lot. So to save some money, some time, and also to be generally more efficient and sustainable, we're looking into in-situ resource utilization, ISRU. And ISRU is, for example, using regolith to make concrete bricks, or using the ice to make glacier habitats. But I think also a very cool type of in-situ resource utilization is going even larger, using whole structures that are already in place on the lunar, or actually beneath the lunar surface, which are lava tubes, like this lava tube. I think this is the Surtshellir lava tube in Iceland. If you haven't been there, please go there. It's amazing. And another fun way, or very interesting environment that is within the lava tubes is the research that can be done. Because the environment is so protected, there has been no radiation, there has been no meteorites, it's also generally unaltered. So this means that we can do a very unique type of research in a relatively pristine environment. So the rocks that you will find inside those caves are exactly the way as they were left when they were formed. And especially maybe on Mars, where we also have lava tubes, this might be able to give us an indication of fossil life. This is a video that I've made. There's another train. Yes. Okay. So this was in Hawaii. This was almost 600 meters. We should not lose our luggage unattended.
Pour des raisons de sécurité, veuillez ne pas laisser vos bagages sans surveillance.
Yes, okay, thank you. We know it. Then we will continue. So research, and this video was taken almost 600 meters from the closest entrance into the lava tube system away, which I think is a crazy amount to still find this much life. And there have been quite some research already to see whether these precipitates that you can also see as the white stuff or the white powder, or even space cocaine as we'd like to call it during our missions in high seas, whether that's organically formed or whether it's inorganically. And the conclusion was that there should be some organic processes working as a catalysator in order to make sure that we have these large amount of precipitates. So looking forward to the Chill Ice mission plan, we are going to Stefanshetlir, which is a lava tube located in the Hattemudderklein lava Iceland. And the habitat will be located on the easternmost entrance, so the most to the right in this image, in the large gallery, which is approximately 65 meters horizontally deep and approximately 10 to 15 meters beneath the surface of the rocks. And this is a little look from the inside. So as you can see, it's a relatively smooth surface and it's really a large cave and it's large enough to build a proper habitat. There are actually multiple lava tubes here in the neighborhood. So we are going into Stefanshetlir, but you also have the Surtshetlir and the Hulduhetlir. The Hulduhetlir means hidden cave, and it is because there are no openings to the surface there, which I think is also a very cool way to introduce new types of research on how can we discover these types of lava tubes or subsurface cavities without being able to go in there, or without wanting to go in there, maybe because it's such a pristine environment. Yeah, just some more pictures also taken from the outside. So you can see the cave system on the left from an aerial picture. And also on the right, you can see the entrance to the cave. It is quite deep, but it's also quite steep. So this might be a problem for our astronauts, but I think it's also a very fun challenge. So next step, Chill Ice. Again, it stands for the construction of a habitat inside the lunar analog lava tube. It's the Iceland campaign of Euro Moon Mars. This is also our logo, which has been made by Esther and your sister. And I think it's a very beautiful logo. I think we can be very proud of it. So, considering the objectives of the mission, we have been working on this mission since 2018, focusing on different aspects. So at first, of course, we wanted to discover suitable lava tubes and test them for sediment habitability or feasibility of constructing a habitat inside of it. And now this May or this June, we are actually going there and we will construct a little habitat there. But there will be some boundary conditions, so the astronauts will be working in simulation. So like the Apollo astronauts, they will be having limited vision, they will have limited movement, but they also have limited oxygen. So we will give them 8 hours of oxygen in their astronaut suits. And afterwards, if they have not successfully set up the habitat and the communication and power supply systems, well, just like on the moon, they will die. So then it's a mission failure. But of course, we will do everything to train our astronauts to make sure that there will be no mission failure and that there will be 2 very successful analog astronaut missions. So overall goal, to build a habitat inside a lava tube in 8 hours or less. Yes. Yeah, a little bit of an overview. As I already mentioned, Bernard and I have been working on this mission since 2018, when we first went to Iceland for a scouting campaign. It's a preparation mission. And we also had sorry, I have some pictures. Yeah, scouting campaign. So we went to several lava tubes and lava fields in Iceland, and we concluded that the Hattemudderklein lava flow was by far the most suited because there are already some earlier damages from tourists. So there's less pristine environments that we could potentially damage as well. During the Igluna campaign, we also had a test of the instrument bench. So we did a lot of research on glaciers, but also on solar observations, which we will continue during our mission in Iceland. And of course, we also had the Envoy mission last summer, where we went back, we went to the ground, we again got stuck in the ground, and we had a lot of fun. But we also developed a larger network within the Icelandic space sector. Yeah, as I said, networking, also a very important part, of course, of the mission, especially looking forward after this initial mission. If everything goes well, we would like to be able to host a more permanent research type. So this also is incorporated in our overview. So we will have several phases in our mission. Of course, we will have some preparation on site, which may also consist of digging some ice out of the entrance to the cave. Then we will have analog astronaut training, where they will, of course, also receive medical training, psychological training, but also instrument training. So how to use the scientific equipment and the research projects that are being sent with them or with us to Iceland. Then phase 2, I guess, is the coolest part, where we'll have 2 days of simulation. So it's only going to be a 48-hour analog mission, during which they will test the setup and sleeping and research EVAs during stay on or in the lunar surface. There's another train. There are a lot of trains here. Then we'll have 1 day of local outreach and information exchange. And then we'll have another 2-day simulation. So phase 2 and phase 3 will be repeated. And then, of course, we will also have a wrap-up, during which we will also have national outreach. So we will leave the habitat in place in the habitat inside the lava tube, and invite some VIPs and some local press to come and visit the habitat and take some nice pictures, of course. And then we will start working on the publications of our research results and all our hard work. We actually already have 5 publications or conference abstracts about all the preparations that we have done. Yeah, I think this is just the overview that I already talked you through. And of course, we also have some spare days at the end. In case anything goes wrong, maybe we need to fix the habitat, maybe we need to fix the suits in between, and we have a little bit of time to spare. If there is nothing else planned, of course, we also host a research campaign in which the analog missions will be incorporated. So there's always going to be more research that can be done in situ, in and around the habitat, or into the glacier, which is located almost next to the flow. And as already mentioned, phase 7 as well, which is a continuation of a more permanent space analog habitat like high seas, like MDRS. We are planning to have a more sustainable habitat inside the lava tube, in which we can host a research campaign and researches for at least 7 months per year, because of course Iceland is quite high up and the winters there are quite tough. I see that my 3D outlook has failed a little bit. This should be an analog picture. So if you have a red and a blue eye, I think you should be able to see this in 3D. But for now, I think we better continue. Yeah, so of course, a very big thank you as well to all our support, all our mission partners as well. The Kwantlen Polytechnic University for supporting us with the construction of a habitat, Reykjavik University with the communication systems, Astraland Interplanetary Agency for the spacesuits, the Icelandic Speleological Society for helping us get the permits, Space Iceland also with their contact within Iceland, Lio Foods for distributing us with astronaut food so that our astronauts will not have to starve, but also some other universities and research groups like Euromoonmars, EDWEC, the VU Amsterdam, Fourth Planet Logistic, Lunar Zebro, TU Dublin, and TU Delft. And of course, if you are willing and you find this a very interesting project, you can be a very big support to us as well. We have a GoFundMe campaign, and you can always just donate some loose euros, dollars, yen. I'm not sure what you're using, and we will accept everything, and we will make this mission into an even bigger success. So thank you very much for your contribution. Just to recap very briefly, Chill Ice, we will focus on the exploration both on Earth and beyond Earth, developing new technologies on how we can help humans survive on the lunar and Martian surface, focusing of course on human well-being, not only on the Moon and Mars, but also looking back on Earth. How can we help the humans on Earth with our settlement preparation and eventually, hopefully, solar system colonization by going to the Moon, to Mars, and beyond. This is also our slogan of the mission, from into the earth to into the universe. Thank you very much. If there are any remaining questions, feel free to shoot me an email at mark@chillice.com. Send them either here in the chat of the Zoom, send us a message on the YouTube. And yeah, looking forward to having you join either virtually or in person in Iceland during our campaign. Thank you very much.
Thanks very much, Mark, for showing us the presentation. Sorry, it's definitely a very interesting project, as I guess you can all see. And thanks especially for joining us, although you're in Schiphol at the moment. Took the time out of your day, so thanks very much for that. Anyone have any questions, either in the room or on the Zoom? Oh,
so yes, I have a question, because I understand today you are to announce the Chile Ice astronaut. Is that still the case? We have planned a slot for you. Yeah. And we should also mention that you have talked about all this phase during the campaign, but it's very important also to be very well organized in the way we organize the roadmap, the countdown towards the start of the campaign. So phase -5, -4, -3. And so what we had a discussion yesterday with you and with Sabrina and Chile Ice team, that we are going to use the opportunity to organize a field workshop, Chile Ice field workshop. So this will be on the Saturday, 17th of April. And so it will be on one hand, on the morning, we are going to bring some of the assets that we have here, the lander, some of the instruments, in a place called the field. And then in the afternoon, we will try to organize a Chill Ice workshop, where I think it's very important that we have also a structured way to interact, to bring all the participants. And I want to announce that this will take place in a place that you will love, Mark, because it will be just by the train station of Leiden.
Yes, more trains.
So the field is a public cultural area that is working together with the Leiden Innovation Center. It's very easy access for those of you that are using the train and bicycle. That would be great. And it will be also the opportunity to bring our Moon Gallery exhibition. We'll have a series of events planned, but on 17th of April, it will be really focused on the preparation, on one hand, of Chill Ice, and we'll have also our team that are preparing their campaign for Poland. They will also be there, so there will be also a good way to explore the synergy. I wonder, maybe it will be also just before we will have some of the Chile Moon Mars LICA precursor campaign. So that a good way also we can share some of the expertise between the different groups. So that's the short term. Now, what is the plan in terms of introducing the astronaut? Do we still plan to do it and make a news release today, or is that, or do we want to wait?
Yes, we have made a nice video. I think Kevin already has the video as well from Sabrina and Jamal. And
I can play that now. I can stream it if you want.
Yes, please do, if you have it readily available.
Oh, sorry.
These are also some of the pre-selected members of Chile Ice that have joined us.
Okay. Let's see. Okay. Can you hear?
No, I don't have sound. Did you also share the computer sound of the Zoom?
Dear passengers,
So always be careful. We always need to rehearse. We always need, when possible, to be co-located. You know, so I think that you have a great energy, great work. We have to be careful to also show, be ready, be professional. It's space preparation. So always we should try to make the effort to rehearse the thing before, in particular if we want to make a big splash. So with this announcement, let's act as a space professional in the way we release some of our product. So first, I want to show, like Adrien has done, beautiful presentation and so on. And so we have to be very careful in the image we project outside, that it is not only, you know, creativity, innovation, energy, but also we have to inspire credibility and professionalism in the way. And this requires to test. Also, you know, we had, for instance, two systems here, because we always know that one can crash. So, let's make use also of this beautiful Leiden Innovation Center a bit as our temporary headquarters for the next week. Okay, so we have one astronaut intervention here to look at it.
Very sorry. Very sorry. I can't quite get the sound to work.
Okay, so now maybe, yeah, so there's a video. In any case, if there's a recorded video, we will pass it over the lunch break. But is there also some written news of introduction? You know, that's with a name and still pictures of the people? Because also, if you want to make a release to the news, they just want simple information: the names, the profile, the pictures. This is the next stage. This is when we are going to target the TV, broadcast, CNN. Okay, we can send them this video, but it's also very important to do the thing step by step in the way we communicate. Yeah,
Yes.
excellent.
So then I think it would be best, and of course also the most professional, like the real rocket launches as well, to postpone the launch date by, I think, 2 hours, because Sabrina is also joining us later today, and Charlotte as well, and they will be able to give us a cool and very great informative story about everybody who is involved as an astronaut within the Chill Ice mission. We will, of course, also release the video to you and to the general public.
Okay, that's good. So let's do that like it is a rehearsal of what we want to do later in the open with the public.
Yes. Okay. Thank you very much.
Okay, yeah, sorry again. I didn't quite rehearse playing the video. So hopefully we'll get a chance to look at it later on. Yeah, I can try again if you want. It's 2 minutes. 2 minutes? Okay. Okay, yeah, rehearsal. Perfect. Okay.
We still have 15 minutes before the next talk by Matesh. So we respect the timeline. Yeah.
So let me know if everyone can hear. Freeze. Okay.
Beautiful. Bravo. Beautiful video.
Actually, okay. So I just read the message there. Was anyone able to hear? No? Oh. So no one on, okay, unfortunately we were all listening and I didn't realize the Zoom. Okay, so we'll, again, this is the practice round, hopefully, and I'll fix it for later on. You need to unmute.
Okay, excellent. So this was the kind of a rehearsal for ourselves. So you see, yeah, for this type of event, it's very important to do some rehearsal. Here we are among ourselves. That's a good learning experience. But to say it's a very nice product and what the Chili's team has done to get this individual input. So this is now it's very important also to include some basic, material. So we have to be careful that we are in a time where we are overwhelmed by, by videos, by all this material. Let's also secure, some of the basic information. And for instance, if we want to address the media, or if we want to address also even social media, it's important that we have also, when we launch an event, a kind of a quick fact sheet. We can also distribute some written information. Is there any journalists in the room? Journalists? No? Journalists are lazy. So it's always very important to write down, the story for them. So you have to write down a nice catching title. Yes, astronauts selected for the next campaign, and then put some of the information where they can just copy and paste and write their article. And then after, okay, the materials that you have put together, which is the interview of the different crews. That's a great material that after you have attracted the attention of media and of also the community, they can go and even reuse, for instance, in some media channel. So, okay, that's great. So eventually we would, so do we plan to have some of the members of Chili's online later? Or
yeah, hopefully. I think Sabrina and Charlotte might be joining us later.
Joining us in the Innovation Center.
I think on Zoom, but
okay.
Charlotte has to confirm, hopefully, if she gets off work.
Yeah, in any case, we have a slot during the lunch break where we could broadcast the video. We have to check that the sound is working good on the YouTube broadcast when we spend the video. So we have like a 20-minute lunch break. So anybody else is from the Chili's team? Because we still have
there's Roberto. If
Roberto, yes. So
there's anything you might want to say.
Yeah. And
you're on mute.
Now you can hear me. Okay, that's fine. So hello everyone, I'm Roberto. I'm an Italian student from the Politecnico di Torino, and with Aeromoon Mars I'm working with the Chili's team to design a smart habitat, which is located in the lava tube. And in particular, I'm working on the system architecture. So basically design the main systems like the power system, the electrical system, the communication system with University of Dublin's. And in this moment, I'm working with team to define both the equipment that will be bring to habitats, and then to estimate the power consumption to design the power system, basically. And I will be the support for the mission during the campaign. And that's all for the moment. I'm also working with publishing the missions, basically with public quiz that we will do also, I think, next month in April. We will do another public quiz to gather a bit more financial support from our stakeholders. And that's fine, that's all. So it's a very great mission. That's all for my side.
Okay.
Thank you very much.
Thank you.
Okay, I guess.
Okay, so I think that if there is nothing on Chili's, so we will. Yes, so also important to be structured. We had dedicated this time slot of 45 minutes to Chili's. So it's like in space. If you have a time slot, organize it and be here. We have the chance that we have now for the first time in 1 year. We have the ability to organize a physical meeting. So let's make use of it. Now we have been spoiled. We are used so much to do virtual meetings that we take it a bit easy. But let's use a chance to do the work together. Hopefully that will also expand this time. So we have a bit like 5 minutes time before we move to the next talk to discuss. I mean, all the campaigns that we addressed this morning. So are there some more questions related to the EMMESI campaign or the Chile Moon Mars from the participant in the room? So what I want to mention is that clearly you have seen a great campaign that was performed in Chile. There will be some more work that is being there now in a kind of independent way in these current times. But at some stage, we will be very focused to try to organize a strong campaign in Chile. End of December, beginning of January, we will optimize the date. From what we heard from Adrien, there could be a capacity for about 10 of us from outside Chile to come and join this campaign. It will be very research-driven in science, in technology, and also in simulation. So we are going also to use some of the prior experience, like the MPOD campaign and some of the activities we are conducting here to prepare some of you to eventually join as field participants, but also as remote support. So I think it will be a key objectives for the end of the year for us. You want to add something, Adrien?
Just to see that it will be flexible. So we have some objective. We have a kind of playground, which is this Oros del Salado part. We have some objectives we want to do. For example,
I see on Facebook. I'm about to.
There is the Tres Cruces. There is the Tres Cruces mountain, and on the top of the Tres Cruces Norte, there is a lake. So it's above 6,500 meters. You need to climb a glacier to go at the top, and we want to do some sample of this lake, which will be very interesting. This is mountaineering, so it will depend, in fact, of the profile of the different people will come. If we are 17 people, because the capacity of the expedition is 17 people, 10 from Roman Mars potentially, we can make several teams. And also in the planification of the campaigns, for example, there is some people we can come, I don't know, with rovers, we can adapt. And it's not a plan. For example, if it will be a scouting campaign in the playground we know, the Oros del Salado region, or if we try to do also some exploration in another part of the region, or even to cross the Argentinian border and go in the Catamarca regions to do some fieldwork. This is a little bit complicated due to administrative constraint, because if you are coming from Europe, then we will need to arrange, for example, some authorization to go in Argentina, but it's possible to do. So there is a flexibility, and the sooner the people will have an interest to the campaign, the better we can organize and try to optimize, in fact, the will of the different people who will come.
What also I've heard from Adrien, so there is some co-funding available locally, and so that's a very important and useful aspect that will make the campaign participation very affordable. So that's so we have also great logistic support, and you have shown some of the facility, the experience. Also, I have very much appreciated how you started to connect with the group of Sarah, and in terms of analysis of samples and microbiology and so on. I think that this will be also enhancing both the preparation of what we want to do the campaign, but also the research output. Definitely. Sarah, you have some comment?
Definitely, I think it's an extremely interesting area to investigate and to further investigate. There is not much information, so there is really a need for this type of research, and we are discussing with Adrien to further investigate the microbiological part, because it's a unique opportunity and a unique place. And yes, indeed, there is really a lot still to do on that, but a bit more news in the coming weeks. But certainly one of the places in the world to visit as an extreme environment.
Okay, excellent. So another comment. So in the area of the Year-Moon Mars ICES campaign, as you know, we are planning 2 campaigns of 2 weeks. That will be in the month of November, and that will be also coordinated with international workshop that will be held in between, where we invite some very important partners from NASA, from other space agencies, from academia, from industry. And also, so as soon as we have done the MPOD campaign, which is the object of our next session, we are going to work very hard to organize the preparation for the ICES campaign and for the Chile Moon Mars campaign at the end of the year. But at the moment, we are really focusing on the near-term campaign and as well in the publication of what we have done in the previous years. In now serious articles, we have got a number of Lunar Planetary Science Congress posters and so on. So we'll circulate that. And the next step in the next month will be, in addition to the preparation of MPOL, will be the publication of what we have done in the previous years. So based on that, any comment?
I have two questions.
Yeah.
Do you have the date for the ICES, in fact, symposium, which will be held in Hawaii? Because for us, it will be quite interesting to come, for example, just to have contact with Hank directly, physically.
At the moment, the ICES campaign is November, so 2 weeks first campaign, and in the middle, mid-November, we will have the workshop that allows the team from the two moon-based simulation to be part, show their result. So the workshop would be like 2 days in the middle of November, but we will consolidate exactly the date and also activities that will allow the participant to the workshop also to visit the ICES base itself and all the venues that are relevant.
And also for the Europlanet events in Helsinki, you have some news?
Yes, the Europlanet event in Helsinki at the end of September. At the moment, it's still going on as an in-person event. So it's mostly an event to present some of our results. There is a call for proposing sessions. And I think this is in the next 2 weeks, we are going to propose some sessions. So we will coordinate how we could involve some of you in proposing sessions and also showing us some of our work. We try also to coordinate it with the possibility of visit of an underground facility, which is close to Helsinki, where we have been invited to organize a mini underground workshop. I think it's like 300 meters below below ground, and on all the mine facilities, and we could also see prospect for future simulation. Okay, so that's how we wrap up. Now I give back the floor to our chair, Kevin, to introduce our next speaker, Matej.
Thanks very much, Bernard, and thanks for everyone staying with us this morning. Okay, next we have Matek from ISS Columbus Flight Controller. If you would like to maybe share your screen.
Sure, just 1 second.
Perfect.
Yes. Right, just let me know if this works. Should be loading about now. Yeah. Okay, so hi, my name is Maciej Poliacek. Also, it's written wrong on the program as well, but that's just a minor thing. By the time over the years abroad, I've got used to this, but that's okay. So I'm here today to talk about ISS operations. We have very limited time, so it's going to be just a very high-level overview. If you are already an ISS expert, this is going to be quite boring. But in case you would like to know more, then yeah, this is like a primer, let's say. And yeah, I'm in the Columbus Control Center, so this is going to be from a Columbus perspective primarily. So a little bit about me in the first place. So currently I'm working in DLR as a Columbus flight control engineer. At the same time, I am working in a startup that I have co-founded. We're focusing on ground segment. And previously, I have worked into Slovak companies. One of them is Robotech Vision, which is focused on mobile robotics, rovers, drones, and AI software. You can see in the bottom right a picture from HiSeas, where we sent a little teleoperated rover for testing, and I think it's still there. We've also worked on autonomous driving, but sadly that rover was too big to be sent to any of the analog sites, but perhaps at some point in the future. And the other company I worked for was SpaceManic, which is a CubeSat integrator, and with the satellite that I worked on is actually launching this Saturday. So yeah, it's launching from Baikonur. It's a gamma ray burst detector mission. And for me, it all started at ESA as a young graduate trainee, where I also met Bernard, and that's basically where this whole space journey started for me on a professional level. On top of that, I also worked for some habitation concepts for Venus, Mars, and Moon. One of them actually recently won a first prize. It was the moon-based design with the Moon Society. So yeah, we're very happy with that. And also I took part in an analog mission at Lunares in Poland. This was our 2-week mission in 2018 with a crew of 5. And I guess what Lunares really shines at is the fully enclosed kind of habitat with the EVA area being built inside the hangar. So you can really test human factors in terms of isolation, in terms of regulating the day and night cycle. You can really decouple the crew from the day and night cycle you would have on Earth. So yeah, some more pictures. We stayed purely on freeze-dried food. We took care of some livestock. So here we had earthworms living in regolith soil. And yeah, we did a bunch of physiology experiments as well. If you'd like to know more about this mission, then we have a paper published, first as a conference paper from IAC 2020. It's the overview paper. We have now also sent it to Bernard to publish in the Science and Technology. And we have another paper coming up with the at the GLEX 2021, which is a data paper from our physiological data. And this is basically going to be open access to all of our crew data in terms of daily measurements of weight, body fat, heart rate, food consumed, water in and out, and all these sort of things. So if that's something that would interest you in terms of human physiology, yeah, we'll have roughly 4 weeks of 5 or 6 crew members each. So yeah, lots of data to analyze if that's something that interests you. So to the main topic, ISS. Here's a bit of a refresher if you are not familiar with what the current state of ISS is. This is all the overview of all the elements with the convenient color coding in terms of who's responsible for what module. There's a slight error in this picture, which is the Zarya, which you can see roughly towards the left in the middle, which is colored yellow, and it should be really red because it's a Russian module. But actually, it's good that I can point your attention to this because this is basically the point that separates the Russian segment, where everything aft of the Zarya module is part of the Russian segment, and everything forward of this module is the USOS, or the US Orbital Station. And basically what we colloquially call the American segment also involves all the other international partners such as Canada, ESA, Japan, and a bunch of others that have some smaller contributions here and there. So this goes hand in hand also with the ground infrastructure. So the orbital kind of internationality of the station also is represented on the ground. We have the Johnson Space Center in Houston and Marshall Space Flight Center in Huntsville taking care of the American, the NASA hardware. Columbus Control Center is where I'm at, which we take care of the ESA contribution. The Moscow Control Center, of course, takes care of the Russian segment. And in Tsukuba, we have the JEM Control Center, which takes care of the Kibo and the associated Japanese hardware. And the centers themselves have their own second names, let's say. So MCCH means Mission Control Houston. POIC is the Payload Operations Integration Center in Huntsville, which is taking care of NASA payloads. COLCC is Columbus. This is us. MCCM, Mission Control Moscow. And SSIPC is a convoluted Japanese name for Space Station Integration and Promotion Center. And that's what they that's the name for their mission center for these ISS activities. So as you saw, we take the Americans, the NASA basically takes care of their payloads through one payload integration center. In Europe, we do it a bit differently. We have several what we call user support and operation centers. This is a bit of an older picture because something like the Trondheim USOC doesn't really operate anymore. Same with the Denmark one. It doesn't currently do much, but something like Musk, Biotesk, and the CADMOS are still active, and they basically, what they're tasked with is performing the payload operations. So they basically we give them access to the hardware on the station, we give them power, we give them data lines, video lines, and then they can autonomously conduct their research on the stations without intervention from the Columbus Control Center. Of course, we take care and make sure that anything they're doing isn't causing any harm on the station, if everything's acting nominally. And of course, we support them whenever they need anything from the system side of the Columbus module. So just to familiarize you a bit how we split the responsibilities. Of course, it isn't just one team with a random bunch of people. I'm sure this is clear to everyone. This is the way it's been done since Apollo. So we have the flight director, who's the central point of decision-making, and is also the integrating point, coordinating between the different teams. Flight director, of course, talks to the ISS director, which is the NASA director, who is then responsible for the entire American or the US segment. Stratos is the role that I'm training towards, and this is the systems role that's basically involved. It's the only commanding role we have in Europe that's taking care of the system hardware in terms of monitoring and in terms of basically reconfiguring the system. Cosmo is a stoppage position, so these people track where all the items are on ISS. When they get moved around, they help the crew locate hardware or tools or whatever they might need. Comet is a part of the planning team, so these guys are hard at work pretty much from months before the mission, and they also then support the missions on several bases. So it's in terms of months, but then also in terms of weeks, and then also on the day, they make sure that the timeline is flowing as it's supposed to. Eurocom is the communications. This is basically the European equivalent of Capcom, the person who, actually the only person who talks to the astronauts, and the only other person who talks to the astronauts directly is the flight director in case Eurocom isn't available. And apart from all these positions, which are the flight control, we have the ground control as well, and these guys help us with the infrastructure on the ground. So they make sure all the telemetry and the telecommands are routed correctly, that we see the correct data, that we have all the right software loaded, and yeah, we can send the data the way we need to. I don't know if I have the time, but I wanted to quickly give you a kind of a surface information on what I consider the three main branches of this business, let's say. So I would break it into systems, payloads, and operations. And this is what we train to work with. And this is also what the crew learns to work with, because they're like the cornerstones of the whole thing. So systems, of course, is the infrastructure, is the hardware, is the station itself, you know, the Columbus module. We, on the ground, of course, do the monitoring, we do some maintenance. For example, we have a lot of redundant systems that we switch around so that they are used equally. And of course, as I mentioned, we allocate resources to the payload operators when they need power, when they need data lines, and etc. Payloads, of course, deliver us all the data and all the science. It's the main reason why we have the station. And as I said, that these USOCs in Europe, they activate their experiments, they monitor their payloads, and then they also feed back to us if there's any problems or if there's any situations they think we should know about. And then operations is basically what ties everything together. It's procedures that we learn, you know, how to do things. It's flight rules that govern what we can do, what we cannot do, how to respond to situations. And when those situations get really complex and dangerous, then we also have emergencies, which I would say is a separate category in terms of how we respond to them. Yeah, here I listed some systems. The ones in the bold are basically the ones we have in Columbus, but of course there's other systems like robotics and AOCS we have also on the NASA side. We don't have access to them from Columbus, but just as an overview. And yeah, here I wanted to show you some quick diagrams of how a rather simple looking system or something with a rather simple purpose can get quite complex when you realize all different interfaces that are between there. So I'd like to draw your attention to the condensate heat exchanger, which is in top in the middle. And yeah, this is just the water loop. This is basically how we run water through Columbus for cooling of hardware or for also cooling of the air. So if we want to cool the air, we have to run the water into a core, which then basically cools the air that passes through the core and uses the cold water to cool it. So this is how the thermal control system interfaces with the ECLS system. And then, of course, the same water loop is also used to provide cooling and provide water as a resource to the payload. So suddenly you have something very simple in principle, having a lot of interfaces and of course a lot of individual components that all generate telemetry and all have to be commanded from the ground, and suddenly something as simple as a water loop can become a very complex system. And I'll use this payload overview as a connecting point to the payloads. So here I chose to display what is called an ISPR, an International Standard Payload Rack. This is basically kind of a standardized way how we tidy up payloads into kind of more or less standard format. This is mostly for the bigger payloads. I chose some examples to show you roughly how they can look. This is a life support rack, which basically takes CO2 and produces oxygen for the crew to breathe, and also can produce water through a Sabatier process. Yeah, it's a demonstrator of showing life support, which we could use for longer distance travel. And here's a biolab, which is a Columbus experiment track for biological experiments. You can see that the format is the same, and maybe some of the modules are the same as well, but of course the insights then would be custom to the experiment itself. However, we do enjoy some level of, let's say, standardization or modularity. For example, the computers that govern these racks are the same. Or for example, if you look at the bottom of the rack, you see the interface with the station. It is also the same between most of the racks where you have power and data lines. So yeah, there is some overlap, but of course, it's all adapted to the experiment that's installed. Aside from that, we have some additional payloads. So not everything is in a rack. For example, we want to use as much of the station as we can. So there are some other payloads that are literally just placed wherever we can. I chose AstroPi because it's a student and probably one of the simplest payloads we have. These are literally just like floating in Columbus or in other parts of the US segment. And then we can also utilize the outside of the station for example, atmosphere experiments or for vacuum experiments or anything that where we want to expose the experiment to the hard vacuum of space. And of course, nowadays we're moving towards commercial payloads as well. So we have ways of integrating payloads from companies or from private customers who might want to do some research on the station. The Bartolomeo is an external facility, and IceCubes once again is in an ISPR in a dedicated portion of a rack. Okay, this is my final slide. So I wanted to tie everything together with this operational concept. So as I mentioned, flight rules are the onboard laws that basically tell us which situation may arise, which situation we are forbidden of, let's say, causing. Yeah, so this means we have rules saying that we shouldn't maybe reach certain configurations which could maybe deteriorate the mission or cause some dangerous situations. For everything, we have procedures. So it's basically like a checklist or like a step-by-step document which tells us how to do things. And also we have some approaches for off-nominal situations. So if we violate some limits, if we get into a situation where we have violated a flight rule by accident, we have automated and manual responses, and we have, of course, procedures for this as well. On the ground, we make sure that all the automated responses are always functioning the way they are. If they are not, we have to intervene and maybe do some things manually. And of course, we guide the crew with whatever procedures they might have, because of course, we can't expect them to know everything. They learn the most critical and the most common things by heart, of course, but we're there to give them a hand in case they're not sure or if in case they need some assistance. And the final thought I want to leave you with is the order of priorities, which we always follow. First comes the crew, then comes the vehicle, and after all that is safe and secure, then we focus on the mission. But yeah, if something needs to be changed, first sacrifice the mission all the time. If the others have to be at risk, let's say, then we have trouble. As far as I know, this hasn't happened yet, but yeah, this is the order of priorities, and hopefully this is something you'll apply as well in your analog missions. So thank you for your attention. I know it was a very fast, very shallow dive into things, but if you'd like to get in touch and if you'd like to talk about these things more in depth, or if you'd like some more resources, feel free to drop me a message. I'll be happy to discuss these things. Thanks so much. And thank you, Bernard, for inviting me.
Thank you very much.
Thanks very much for the great presentation.
Yeah, we have learned a lot. And for those of us applying for the ESA astronaut, I think that what you have shown is very useful. So I hope that some of you that are planning to apply will make use of Matage. and that's also something that we want to foster. So that's this view of the Astronautics Training Academy. Give you some material, sharing experience, networking, so that in your professional project, you will use it and will receive and give. So Matage, that's exactly the spirit. It's amazing.
Is there anyone that has a question that they'd like to ask Matesh? No. Okay. Well, yeah. Thanks again. I know I found it very interesting seeing everything involved with communicating with the astronauts. So I guess if we were
just one thing. In any case, if you have some question, you can always write them in the chat, and then at the end we can collect all the questions and we can direct or answer them. Make use of the chat as you wish to have more interaction with the speakers and all the participants.
Okay, next on our list is Agatha from the Analog Astronaut Training Center. If you'd like to share your screen.
Of course, good afternoon, everyone. I hope it is for all. Good afternoon. Let me do this, where I have it. Share the screen. Yes, I hope you see it now. Okay, so thank you very much for invitation to this interesting conference workshop. I would like to present our activity, what we do in Poland, in case of exploration of future human exploration. And I will speak about education, research and technology development at Analog Astronaut Training Center, which I'm co-founder. Well, everything started at ESA, European Space Agency, where I was a postdoc in advanced concepts team. And one of my concept projects was time architecture. So the perceiving the time in space, how astronauts perceive the time. And because, of course, I made these concepts in ESA, I wanted to try this in practice and to go to the chronobiological chamber, so a chamber isolated completely from sunlight, from time, and to test if all our hypotheses are correct. So I found one chronobiological chamber in Europe, and this was only for 2 people. Therefore, we decided, I decided, but together with the team, to create our own chronobiological chamber to test this subjective time perception in space for future space exploration. And that is why we were motivated to build the habitat in Poland. Why in Poland? Because it was cheap, because I had my own land, and it was much, much, much easier, you know, because I knew the people and so on. So in 2016, we made a crowdfunding campaign together with my team. But then, of course, crowdfunding was very tiny amount of money, which we needed. And we found an investor who decided to cover most of expenses. And because of this investor, we managed to organize the first analog mission in Poland in 2016. This was very big thing for us, and we were feeling very, very successful. But then many problems came across, and of course, many people started to see the business and money, and everything started to be completely destroyed. But then we wanted to still realize our projects, our dreams. So we were forced to move the habitat to Piła. Why to Piła? Because we were collaborating with a skydiving association located exactly on the airport in Piła. And our friend, the president of this association, he said, "Oh, I have a free hangar. You can build the habitat inside the hangar." And we realized that this is a great idea, especially to run our chronobiological studies with complete isolation from time and from light. The poor history is that we transferred the base in 2017, and we organized 6-7 missions until 2018 in this base, where I was still the coordinator of analog missions there and all scientific projects. But again, because of businesses, of politics, we have no longer access to this base. But we had no choice. We still tried to do and follow our dreams, to do our projects, and we had no choice. We created our own private facility, and now we have no politics, no all forces that can stop us, I would say. Only death can stop us. Okay, so we created the isolated habitat. We call it chronobiological chamber professionally, which is a very small wooden house indeed, but it is adjusted to our project, to our research. So it is, of course, isolated. It contains several sensors, etc. And now we create the real habitat slowly, because we are using our own money and our own funds. So actual status is like you see here. We create now a large facility. This will be really a center, because this is our vision, to create a multiple research laboratories around this habitat. You see here the list, so it will be not only the habitat, but the professional mission control center, pressurized chambers to run several experiments on plants, on humans. We want to, of course, have 2 EVA domes with different terrains. We want to have astrophotography stage. We want to have a radio station, of course, solar power plants, rover testing areas, etc. So you see that our vision is really big, and we need to go forward. Now we expect that in 2022 we will have a ready habitat. And our vision is to develop technologies to enable safe human spaceflight, and of course to colonize other planets, to get this know-how, to get hands-on experience, and to train people that they will really feel and understand that they can go to space. They just need to train. And now I am very happy that Bernard, that Roxana, that Sarah Batu, all these wonderful people, they want to collaborate with us, and they had the common vision to continue this very, I would say, challenging way to the stars. And of course, as Analog Astronaut Training Center, we are not only focused on the habitat and analog missions, but we also are focused on trainings. We want to be future astronauts, so we need also to keep fit, to train. And because of our searching for these kind of trainings, we realized that we can do this as well by ourselves. And that is why we started to provide trainings similar that we are doing. So like skydiving, as you see here, we started collaboration with Human Centrifuge, and we try to test how the body reacts to different G-forces in different axes. And this we can already do this in Poland. We even try to do some science, again, with subjective time perception in centrifuge. So it is not only just sitting and experiencing all these things, but also to doing some experiments. This is very cool to combine these two things, experience and science. And here as well, you can see some experiments under pressure. This is a hypobaric chamber. We can modulate different pressures. This is all in collaboration with Aviation Medicine Institute in Warsaw. During these years from 2016, we trained a lot, and now Matt, my partner, he became an instructor of diving. After hundreds of hours underwater, now we can teach diving, and we can do what we think it should be done in neutral buoyancy underwater to simulate extravehicular activities, EVAs. And now, finally, we had the power to do this. Again, we combine experience with some scientific projects or even business projects. And for example, here we develop a special resuscitation tool instrument to be used in space in the future. This is the fourth such type of instrument that ever appeared. So this is a very, I would say, interesting equipment. We will present this on GLEX in this year. We organized stratospheric missions. This is mainly for students because then they can test their master thesis, their licentiate thesis in so-called near space environment, which is 30 kilometers above the ground. And this environment is a very interesting environment to simulate Martian conditions. There is no atmosphere, very tiny atmosphere, cold temperatures, and very interesting things related with radiation. So you can think of several projects which can be done in this near space environment. And we are providing everything from start until the end. We collaborate with several universities and research centers, and even business companies like Astronika in Poland. They were testing in the stratosphere on our platforms their products. Finally, we organized rocket workshops because we belong to Polish Rocket Society. This all history with rockets started from very, very long time ago. So I was even a co-founder of this association, but I never really built the rocket. This is very interesting. So only I was supporting, helping, but never I made my own rocket. But many people can do this with us, and these rockets fly 400 meters above the ground, and they land safely. So they are reusable, like Elon Musk's rockets. So this is great that once you create your rocket, you can fly many times. The record is 300 times of rocket launches for one model. So we are doing this. And of course, the best for us are analog missions, because we meet very interesting people from all around the world. And this is the most complex project considering organization, logistics, combining research projects. This is very, very interesting and challenging activity. So here you see the typical mission schedule for one day in the habitat. This we did for Lunares. This is actually the schedule from Lunares, from expeditions that we were organizing in Lunares. And each astronaut has its own graph activity for each day. And we educate, we try to connect people, experts, from navigation, from cartography, from robotics, instruments, space biology, space architecture, which are principal investigators to experiments that are performed by analog astronauts here in our habitat. We have different kinds of instruments that can measure either light intensity or radiation or electromagnetic fields. And we have special dresses, suits to simulate as much as possible the conditions of lunar or Martian mission. We have strong collaborations with robotic teams which are making rovers, and even professional rovers. We have access to them, but mostly we collaborate with students that won, for example, a University Rover Challenge in the Utah Desert or European Rover Challenge. Then, of course, we are focused on performing such experiments that can be published later on, so that each analog astronaut will not only have this experience, what I told you before, but will have something strong for their CV. They will have some publication. This is our goal. And of course, we are designing different kinds of tasks, for example, night EVAs and simulated emergency operations. This you can also try to design in the upcoming EMPOL missions. I'm showing you what we have, what kind of projects you could perform here. So of course, different kinds of sample collection. Maybe you want to write some application to recognize the correct sample, to use artificial intelligence, machine learning. Everything is very welcome. We have on board on our habitat different types of regolith simulants, including those serious ones used by NASA or by ESA in their projects. Astronauts, of course, they perform their own scientific projects. They perform like general projects inside the habitat. For example, some projects about stress response, human factors, group dynamics. These are all experiments like for all the crew. And they have some free time to make some nice experiments, for example, crystals, and they can create some arts on board the habitat. The conditions that we now have in the habitat, they are strictly related with experiments that we are still performing, which is a subjective time perception. And for example, after 8 p.m., we have only red light in the habitat. So the normal standard lighting is off. And we have everywhere blue filters for laptops and smartphones. Every year we try to enhance different kinds of instruments availability in our habitat. We are creating mock-ups. For example, here you see a glove box mock-up to test how you can perform some experiments with gloves where you don't have a very nice mobility of your fingers. Here you have a look for a clean lab. Because here we are mostly doing some biological experiments. And this is really a confined space. It is only 57 square meters. You see here already 3 compartments, like a dirty lab, clean lab, and behind there is the bedroom isolated from light. We can realize here some experiments in vacuum, but we have only 3 liters vacuum chamber. So if you want to design this kind of experiments, please consider this volume, only 3 liters. We are also counting on in situ resource utilization, so-called. So if you need some incubator, like 37 degrees incubator, you can make it out of glove box. So if you are creative, you can use whatever it is already in the habitat in laboratory and create a quite good equipment that you need. Of course, we have a 3D printer if you want to prototype something, if you need some tool and you need to make it fast. And several students, they are realizing their projects which stay in the habitat. For example, here, the EPSA team, they designed the aquaponic system and they were working on it. And you see here the final effect, which is now working in the habitat, and you will see it again in upcoming missions. Maybe upgraded version, more efficient. Here you see Roxana preparing agar plates in the kitchen. So we do not have, very fancy white laboratory, but we can keep quite sterile environment, if you make it clean and nicely, there is a possibility to make it. And this you will also do in upcoming EMPOL missions. This is long-term biocontamination project. So you simply make these agar plates and we collect everything what will grow on these plates. And we are looking, screening what kind of bacteria, fungi are growing on these plates. I mentioned you about aquaponics. We also are working on different kinds of hydroponic systems. So you see that we are not only focused on pure science, but also on some technology development, some engineering work. And with this engineering work, we went quite well. So we are now running the startup for random positioning machines. And this just appeared as a need for the habitat. And now we are ready to release the product on the market, which is RPM machine. Oh, this is how it looks, how it works. This is on the right, this is the prototype made by analog astronauts. And now we modified this prototype to make it a better upgraded version, ready to be sold to some universities. All food is controlled and prepared by dietitian. So for each day of the mission, you will have a specific diet with, how to say, the specified amount of proteins, carbohydrates, and all stuff. This is very important if we are doing experiments on the humans, because everyone has to have the same sort of conditions. And in case of humans, it is very hard. So diet has to be the same, all environmental conditions have to be the same, etc., etc. Laboratory, so our habitat, is equipped with many useful materials and consumables. You need to think what you need, what you will need on your missions. So please specify this. And all people who are working with us, they need to consider that we have a day and night monitoring system inside the habitat because of security reasons. Of course, we are not monitoring bathroom and toilet, but you need to be conscious that you will be monitored inside. Then we have 3 types of lighting systems, and we are very proud of it because these are again prototypes, and this is the development of another startup. We want to develop a specific lighting system to synchronize biological clocks and to decrease jet lag symptoms. So this is the first big grant that we finished now, and we got fantastic results. So we are now at the stage that this lighting system will be produced for the market. So this is another thing what you can do inside the habitat. Look how many opportunities and how many even businesses can evolve. In Mission Control Center, some of you already visited this wooden house. It is 4 kilometers from the habitat. You can walk from the habitat, and to reach the MCC, you can drive. There are all options. But here, MCC, Mission Control Center, will stay and work. After the mission, all analog astronauts and Mission Control Center meets at Queen Jadwiga Astronomical Observatory, which is located 5 kilometers in distance from the habitat. And there we have a conference, a workshop space. We are presenting what analog astronauts have done during their mission, what should be done more, etc. So I think this is also good that we have this kind of infrastructure available on site. And to summarize, we are interested in all student projects that may emerge into future prototypes, into some publications, into startups. And when it comes to another thing which is developed now, and we are opening the factory, is the kombucha nanocellulose and production of cloths out of it. I have it even now here. So this is like a vegan skin, and now we start a big business out of kombucha from our experiments inside the habitat. And here are some publications that we made after missions in Lunares habitat. You see some bands that we tested on our analog astronauts, and we tested the allergic response, the contact with skin. And now we know that the material is very interesting. I will tell you when you will come here because this is another topic. Of course, there are many students, PhD students, that they are innovators. And for example, here there was one, Marcel Młynczak, who invented a pneumonitor, and we tested this device on our analog astronauts. And now he has some company and PhD out of it. Finally, as I started this presentation, we still continue experiments on circadian clock and subjective time perception in isolated spaces. Why we want to do this? Our deeper, further vision is to train brain to perceive time in a way that we will get younger. But this is very big generalization of what we want to do. We want to be young, to feel the young age. And of course, we realize master thesis projects, some architects, some designers, they want to have this experience in the habitat in order to create a better their design of the base of the habitat. So this is like addition to their hard work on designing. Also, this is related with artists. Some artists, they want first to feel how it looks, the isolation, all these activities that are inside the habitat, and then they create something big out of it. So here is another master thesis. And we are engaging our analog astronauts with international competitions. Last year, we won Home on the Moon competition, 2 crews, so 10 people. We won very nicely the project of the moon base, especially it was a hospital. And we are also trying to collaborate with people all around the world to create the best habitat in the world, maybe the best research center. And with this idea, we collaborate with Americans and anthropologists, and we will have this year already the pressurized EVA suits, the real ones. Other serious topic that we are still working on is the control of the habitat, sort of like a smart house creation using AI, artificial intelligence, and machine learnings. And Matt is the main boss in this project. So we are using several sensors in the habitat. You can also consider that we have plenty of data collecting in this habitat every 5 minutes. You can use this data to your experiments. How we work: minimum 1 month before the mission, we start to complete mission manual, which is the scenario of the mission. So all people know what they should do during this short amount of time to make it efficient and the best quality. And our goal, of course, is to inspire students to develop in space sector, because there are so many opportunities. At the end, I would like to say that we do not have this fantastic hangar as Lunares habitat to make fully isolated EVAs, but nearby 5 kilometers from the habitat, we have rocks and caves that we can use and train some robotic operations, some procedures in a very nice, beautiful landscape. Now you see, this is just 5 kilometers from the habitat. And with that, I would like to thank you for your attention. And of course, welcome to our habitat, welcome to Poland, and welcome to collaborate with us.
Thanks very much, Agatha, for that. I know myself, and I presume everyone else involved in the next MPOL missions is looking forward to it. Looks like a great facility, and can't wait to use it. Is there any questions from anybody? Also, for those who've just joined, if you'd like, you can either unmute yourself or put questions in the chat.
Yeah, I have one question,
Yeah.
quite personal question. So you are not so far away from the Tatras Mountains. So are you working, do you have some links with the mountaineers community of Poland, which is quite active now?
We have some climbers in our teams, so we can work with them, but until now we didn't have any request from analog astronauts to do this. So if you will inspire us, motivate, we can start collaborating, in this kind of way. I know that you like mountains.
It was, but do you work, for example, with some mountaineer? Because there is some expedition from Poland in Himalayas, for example. So are you working with them, for example, for all the physiologic aspects?
Unfortunately not. We are only training in mountains. We are making ultra marathons and running in mountains. But this would be great to participate in mountain expedition. I know that you are organizing them.
We will have some MPOL participants that will go also after to Chile. So we could become the mountaineers ourselves. And we are going to pre-train them already in the MPOL mission in April, May, and also in August. And I think that it will be good to make some of this link. So yes, amazing experience, expertise, energy, and it's a lot of fun to work with Agatha and the Analog Astronaut Training Center. I think also to
thank you very much.
To capture research that train all these young professionals through research, to research also help them in their career and professional development, and also as potential astronauts. And clearly, I think that those that have followed some of the experience with Agatha or with us, with our Young on Mars Training Academy, let's capitalize on all of this to help you in your professional development.
Agatha, there's also a question from Karoli Schlotter, excuse my pronunciation, but she wants to know which part of Poland is the habitat based at?
Now we are in south of Poland. I know, Karoli, that you remember me from Lunares, and Lunares had much better marketing and PI because, yeah, we were focused on business. These teams are focused on business. So we are no longer in Lunares. I will tell you later. I will write you in chat.
Perfect, thank you very much. Okay, I guess next on our list is Roxana, who will present for the previous MPOL 1 mission. So I guess it's up to you. Share your screen.
Do you see my screen? Yes. Good for you. Okay. So, continuing Agatha's presentation, I'll make a short review of what was EuroMoon Mars Poland first moon analog mission. So, MPOL 1 was a team that was formed by 3 EPSA students, 1 supervised commander that was Christian Komenda from Poland, and myself, so my students Theo Podolski, Emma Forgmaillet, and Michael Klein. This mission was a miracle mission between 2 lockdowns for France at least, between the 16th and the 22nd of October 2020. Our mission, so we were the first MPOL mission inside the habitat, and as soon as we got out, as Agatha explained, we had the opportunity to test the the roles as a mission control center during the EMMESI mission. So these are pictures from the wooden house, the MCC that Agata just presented. MCC for EMMESI that was between the 23rd and the 29th of October 2020. So the way we organized, as you already saw this morning, for those who are here for the workshop, for the communication and the organization of such a mission, we have a flight director that will communicate through the Capcom with the analog astronaut and with the MCC crew. Analog astronauts that produce data. Those data are transmitted to MCC crews, and the crew that is divided in data analysis, medical analysis, and science analysis will take and process this data. What happened during our EMMESI-1 missions? We basically did science inside a moon base. We worked on aquaponics and hydroponics system, on life support system with experiment for reducing the CO2 levels inside in confined spaces. We worked on biocontamination, as you saw also Agata presented it, on recycling, sample returning systems, and with special water that has a high pH, but also we monitored the water budget through and thanks to this experiment with the special water that I'll talk to you later. So, for the aquaponics and hydroponics system, when we got inside the moon base, this aquaponics system looked basically like what you see on the left side of this slide. The mission just before us make this system, and during our EMMESI-1 and EMMESI-2 missions, we improved it and worked with everything that was inside the base, but also with the mission control center. So thanks to this collaboration between us as analog astronauts and the mission control center, we got to have life on moon. So we have the plants, the crest that you see on the right side of the slide. Hydroponics system was also tested. So on the left, there's what MCC crew asked to simulate a power failure inside the habitat, and this way they transfer some of the plants in the non-circulating hydroponic system. And here's again a very good proof of what joint work between astronauts and the mission control system can do. Maintain plants' health, control the parameters, and having no electrical consumption. What you're seeing on the right with the 4 different types of 4 different recipients is because we had the chance also to test the neutral pH water and the high pH water, Aquavia high pH water, and to test the difference between how the plants react in while treated with neutral pH water and high pH water. Unfortunately, the study was too short. The 2 weeks were too short. So this, as Agata invited you, can be pursued as a study during the future missions, and hopefully during the EMMESI 3, 4, and 5 missions that we will have this year. Algae-based bioreactor for a low CO2 level. Our vice commander, that was Christian Comenda, worked on the bioreactor that was composed by 3 different algae microconsortia. And you see here that in MCC, they were monitoring our CO2 level. And we had, like you saw the composition of the base, we have 4 main rooms inside the base, and these 4 rooms were monitored. And we see that the CO2 level was given twice a day. So EMMESI could monitor our good health inside the base. Recycling and compost, yeah, like, you know, you're inside a base, we're inside confined base, and we're producing waste. While on the moon, those waste would have to be really like think of in terms of recycling. So thanks to the collaboration with Vaisselle Écologique ZIPAC, that's an environmental friendly company in France, we had gloves, wet towels, and garbage bags made of materials that were compostable. So one of our analog astronauts, Michael Klein, used 2 jars with soil, and he put wet towels and gloves in it, and then took parameters from it, like pH, temperature, and humidity, during the mission, Ample 1 mission, and then another astronaut, analog astronaut, continued during the second week. As you see in the table sheets that you have on the slide, we took these parameters, but nothing concluent for now. But it's a very good like solution for everything that's reusable, like one-time use items like lab gloves or garbage bags that can be compostable. Now, we are producing science, and we have samples, and we thought through it while being inside the moon base. And as you saw, we had, thanks to the Zortrax Polish company, a 3D printer inside the base. So one of our students and our analog astronauts thought about how to conceive a sample return system, a high pressurized tank with a thruster, and this was conceived for a very small mass of samples, like a couple of hundreds of grams, either of regolith, either of any other organic or sensitive samples that were produced inside the base, the moon base. So this is mainly a 3D printed launcher. We would love to think about it that it could be produced out of the compostable plastic or recyclable plastic inside a base. So this way we had an a closed circuit for the plastic inside the moon base. So you saw in MCC, they were producing the models on the CATIA, and then sent the files to the moon base. And during the night, the 3D printer was very active and was printing the small high pressurized launcher. I showed you the aquaponics system. Know that parts of the aquaponics system were 3D printed with this Zortrax 3D printer. And of course, I left the water on board to present you lastly, but not leastly. So Aquavia is a commercialized water that has a pH of 9.4. It was tested during Ample 1 and 2 missions for the aquaponic and hydroponic systems. In this picture, we cannot see it, but we only visually saw that that crest with Aquavia had a slight different green than the one in neutral pH water. That must be done at least 2 or 3 times again, like scientifically speaking. You need to prove that with more than one experiment. And also we used Aquavia for astronaut hydration, but also for cooking. So you see, during all the mission, we only used Aquavia and we had a special diet for us, for us to be sure that our organic samples that we gave for an ongoing science after the mission would show the influence on our bodies as analog astronaut of this Aquavia 9.4 pH water. Talking about water budget now, it was very strictly monitored. So on daily basis, we would calculate how much water did we drink, how much urine did we eliminate, and the shower, how many minutes we used the shower. That was the water from the habitat. Of course, what's very important is for you to see that we only used once a week the shower. So we respected that we had a low budget of water and we only had to use it once. From the Mission Control Center, a lot of parameters were taken from the astronauts, our circadian rhythm, our moods every day, the food we were eating, our daily schedule, sleep reports, the time of sports and our parameters during the sport sessions before and after, and also the water budget, as you just saw. What's important that our daily schedule took into account the fact that we were adapting inside the base and we needed more last time for some of the tasks we were doing inside the base. Lessons we learned during our first mission is that communication is very important. What was unexpected is that we lost temporarily and we had a blackout during our mission. So we had to manage by ourselves for half a day. So what's important is that we should know each other inside the base, train together. And what we discovered also is that we train on Earth, but as all the astronauts, we find a different environment once we're on the moon. Like, we weren't on the moon, but we went to Poland, and for us, Poland was like the moon. It was really different of what we expected. So, in conclusion, we, like MCC crew and astronauts, should work together for the science protocol, for the daily schedule, and know each other's roles and know the roles we can have inside the base and inside an MCC. So this was EMPL 1. Thank you for your attention, and the floor is yours. If you have any questions, I'll be delighted to answer.
Thank you very much, Roxana, for that. Hopefully you get to we can continue all the great work in the next few EMPLs in a few weeks. So anyone have questions? No?
Yeah, thanks to document and the experience. So we make the presentation also available for the next team, and that you can also build on what was presented and also on what was published. So that's and mission manual. So you see, very useful. So we are working this week to consolidate a bit some of the input, discuss them, and then really complete them for next week. That's the goal before the deadline of 31st of March for the next EMPL 3, 4, 5 mission.
Brilliant. Okay, I guess we'll move on. So next is Roberto from who will do a presentation on EMPL 2. If you'd like to share your screen.
Yep. Thank you. So, can you see
good. Let's try to keep in the 10 minutes and for each of them.
If we are getting close to the time, I'll just let you know 10 minutes and we can continue.
Yes, that's fine. So, hello everyone, I'm Roberto Landolina. Maybe I introduced myself some minutes before. So, I'm an Italian student from the Politecnico di Torino, and I'm doing my master thesis, which is based on the design of smart habitat. And I was during the EMPL2 the commander of the crew, basically. And I supported EMPL1 during the first week, and as a mission control center flight director. And today I will to introduce my crew, first of all, and their experiment, and in general an overview about the mission and the objective of mission. So the first things is the introduction to the members. As you can see, it was a very heterogeneous crew. It was we were 5 people from different nations, from Italy, me, from Canada and Poland, Amanda, and of course from IPSA, the French students, which were Julien, Hugo, Quentin. And basically we were a very different crew members, so it was very interesting also to develop the international aspects of mission. Well, which were the objective of missions? Basically, we wanted to study both the physiological aspect and the psychological one. So basically, we had some experiment for the physical basically aspect, and other related to psychological aspect, basically the memory test and the reaction one, and also some studies about the system of habitat and the relationship with human activities, basically. And we will see that basically my research was focused on electrical power consumption and air quality, and the impact of human activities on the level of CO2, for example, and in general the power consumption. But we have also to introduce the fact that we experiment both we joined both the crew, so as a MCC crew member and as a flight crew member during the EMPL2. So basically during the first week we were the MCC crew member, and we supported the EMPL1 mission. So basically you can see on the left our desk, basically, and on the right you can see we during our work. And we performed also a NIVA expedition during our MCC experience, which we somewhere in some way experiment the life on the moon or on Mars, and basically we enjoyed our time. We also made another EVE activity during the astronomical observatory trip, you can say, and we visited the new AATC center, basically the new habitat, which is still in building. And also we visited, of course, the observatory. Okay, we can go on. And another activity we performed was the observation of moon, basically, and some other fun activity. So you can see on the left our observation moon, and on the right our we can say disadventure, for example, with the transportation vehicle, but it was very, very fun. Here you can see in general, some activities. So work, outreach activities, workshop, physical activities, basically gym and test, and some free time you can see in the middle of the picture in the middle. And here some results of our activities that I will to introduce very quickly in few moments. Okay, so the research, the first things, it was my research. Basically, it was focused, as I said, on the electrical and power system and on smart sensor. Basically, the main question in this slide, you can see the flow, so the activity flow. You can see basically the main question we had basically. So the first things was to investigate which device require in general during a mission the power, the electrical power, and which is the average consumption of electrical power, and how this consumption basically vary on the day, basically over the time, and in general how we could to improve for next habitation this power consumption. And on the right you can see in yellow the function that it was carried out during the mission to investigate this aspect. It is a very important thing because in this moment we are designing new habitat for Moon and Mars, and one of the main things in every studies is to provide to science community as much as possible data about the power consumption, about power device, to be able to carry out a feasibility first studies of the mission and to design with a very reality the missions. So it was very interesting to investigate in first person this aspect. Similar things it was done for a smart sensor. So also in this case, we investigated the variation during the day of CO2 level, the impact of human activities on CO2 level, for example, during the gym activities or during the rest moments. And we also investigated during the Ample-1 mission some corrective actions to reduce CO2 level by means of, for example, of algae. And also in this case, it's a very important thing because smart sensors are an integrative part of environmental control life and support system on space systems. So it's very important to investigate this aspect to provide some initial data for the design of future habitats. Here you can see some consumption. Basically, the overall power consumption was 60 kilowatt per hour, roughly for both missions. And it is a huge quantity, but the main thing is that we had to have a neat heater control and air conditioning, which are very requiring devices. So the power consumption could be explained in this way. So we had to control the air system, and we discovered that in every space mission, the most requiring system is, of course, the environmental and control support system. And here you can see also some operative modes: night mode, night phase, reacting time, for example, emergency phase. And you can see, for example, an estimation of devices used. Here some results also about the air quality. You can see, for example, that we have the ITER value in, for example, bedroom and main room, the galley module. Whereas the lower level was in the laboratory and in gym, and that could be explained by saying that in that area we had also algae. So maybe the reason why we had lower levels was to the algae's activities. So it was very interesting. And of course, you can see during the night, the level was quite lower because, of course, we had not human activities. Okay, so here you can see some questions, some procedure. And another research was focused on space weather. which was carried out by Julien. And basically you can see the monitoring over the time, over the days and the time of the solar radiation received. And it is very important during the mission because sometimes if activities are planned on the basis of expected solar activities. So it is very important to study the variation to estimate when the next particular event from sun will happen, and so which are the main moments to organize an activities. Another experiment was based on the water sample experiment. I think that Roxana told a lot about that. It was the continuation of EMPL1 experiment. And this is an interesting test because it's related to human factor. It is the memory test carried out by the reaction time, in this case, test carried out by Amanda. And you can see that the basic idea was to evaluate during the morning and during the evening our capacity to click very fast when the screen got green, because we had a red screen and suddenly it gets green, and so we were able to be fast in this clicking, and it was very interesting. Here you can see some results, but I don't want to go in depth. And another thing was the test, during which we were a random 5 number, and we were able to replicate the sequence of the number in a reverse sequence, basically. So, for example, 1, 2, 3, 4, 5, and we were able to say 5, 4, 3, 2, 1. So it was very interesting. And also in this case, you can see some results. Here, I don't want to say more because I think also in this case, Roxana says a lot. So it is the aquaponics system before and after with the improvement of EMPL2 basically done by Hugo. And with the support of a 3D printer. And here you can see the results. And finally, also the CAD components printed with a 3D printer of the micro launcher. As said Roxana, it is useful to send samples from the moon to Earth in a very easy and cheap way. And here you can see the results of the work. And finally, our main outreach event, basically with the Italian university, with the Politecnico, with the Polito. We had 400 of people connected, but 800 subscribed. And on the right, you can see the second workshop that we carry out with the Pisa University during the week of mission. And that's all. Thank you for your attention. If you have any question, you can write it in the chat. Thank you.
Thanks very much. Thanks, Roberto. Again, great presentation on all the work you did, and we look forward to continuing it. I think we are going to move straight ahead, and we're a little behind time. So next, we have Roman, Sybil, and Shannon with their EMPL3 presentation. We can't hear you, Sybil.
Hear me?
We can't hear anything you're saying. Roman, do you maybe want to try connect?
Yes. Do you hear me?
Yeah.
Can you share the screen, Sibyl, please?
Also, we are a little behind schedule, so if we could maybe do five-minute presentation, that'd be perfect.
Yeah, that will be okay. Okay, let me present. Okay, can you see the screen? So hello, I will present the EMMESI crew, which will last from 22nd to 29th of April 2021 in Poland. First I will present Sibyl because she...
If you want, I'm back. I don't know if you can hear me now.
Yes, we can.
Okay, sorry for that. So I will quickly present myself. So my name is Sibyl Collins, and I am the vice commander of the EMMESI crew. And who's the EMMESI crew? We're a team of 6 passionate students from 3 different universities, 4 IPSA students from France, 1 from UC Louvain, and 1 from KU Leuven from Belgium. And we will work together on different topics. So I'm in my 2nd year of master in architecture at the UC Louvain in Belgium. And I'm writing my thesis about how inner space can influence social interactions in a crew, the importance of modularity and space appropriation by a crew. And my experience will be to try to modify the space and see how those new spaces will make the team feel different. So maybe with the use of virtual reality. And I will also record a video from the EMPL mission.
Hello, my name is Maël Richas, and I will be the data officer. So I'm from IPSA Toulouse. I'm French. I'm in my 3rd year. So yeah, I'm studying to be an engineer in aerospace, maybe in systems, aerospace systems. So I'm fascinated by aeronautics, but I will be, as I'm a fan of exploration, space explorations, like Perseverance we've seen, I will be working on a rover developed by Shirayu Mohan, who will be on EMPOL 4, and who is studying in Dublin in a technical university. And also last year, I worked on a group project developing a remotely controllable telescope. And so I'll be also doing an experiment with a telescope in the mission.
Oh, hi everyone, I'm Hugo. I'm 20, I'm from Lille. I will be the engineer of the mission. I'm also from IPSA, engineering school in aerospace and aeronautics. I'm really interested about space habitat, and this is why I wanted to join the EMMESI 3. Last year, I worked also, like Maël Alois, on the Remotable Telescope project. And as a president of IPSA Rocket Student Association, I often work with a 3D printer, and I will be glad to work also in this mission. Thank you.
So hi, my name is Marie. I'm an aerospace engineering student in 4th year at IPSA with a major in mechanics and structures. I've just completed a semester abroad at the University of Limerick in Ireland, where I studied aerospace metallic materials and earth science. For a little bit more than a year, I work at the Cité de l'Espace as a scientific animator. I did an animation in front of a large group of people about water rockets, Apollo missions. It helped me improve my public speaking skills, and obviously I learned a lot about space history. Being part of an analog mission is a great opportunity to put myself in the shoes of an astronaut. I'm really looking forward to it. And for this mission, I'll be the communication officer. Thank you.
Should I present Shannon? Shannon couldn't.
Yes, you can.
Yes, Shannon couldn't come today, and she's my student, so I'm just going to rapidly introduce her. So she's a physiotherapist. She's graduated in 2020 as a physical therapist, specialized in internal disorders, amongst others cardiovascular diseases. And for the moment, she's following a master, an advanced master in space studies at the Catholic University of Leuven, and it's a joint program together with the University of Ghent. And she specialized in studying the implication on health of human spaceflight. And for the moment, she's doing her master thesis with me, so at the Belgian Nuclear Research Center, Sarabatu, in the radiobiology unit. And she's really looking at the impact of space conditions on the cardiovascular adaptation and diseases following spaceflight. And she hopes to take some human samplings during the EMMESI mission and to look at the effects of isolation and Moon-Mars habitat. And she's extremely thrilled to join this group of very enthusiastic and motivated participants of EMMESI.
So hello, I'm Romain Lafabrie. I'm also a student from IPSA, which is a second year of engineering cycle, and I'm specialized in space launchers and satellites. I did a semester abroad in Gothenburg in Sweden, where I studied some astrophysics. Then I also did some space-related project with a space experiment and also a CAO space project, which was to design a complete reusable space habitat capable of carrying 10 people to Mars. And we wanted to design a space habitat. I will probably do the spectroscopy experiment with Hannah, which is part of the EMMESI mission. And I'll be the crew commander of EMMESI. So thank you for listening us, and these are the beautiful members of EMMESI.
Thanks very much, everyone involved with the EMMESI mission. I know I look forward to working with you next month. So yeah, I guess moving on. I'm going to present for the EMMESI team. So 1 second, I'll share my screen.
So we had planned our lunch break now. We are a bit behind. We are doing it at the same time as we are hearing the speaker. That's a normal practice. Yeah.
Okay.
EMMESI.
Yeah. Okay. So EMMESI. So EMMESI will be from the 1st to the 8th of May, and in Poland. The crew will consist of myself, Hannah Riley, Gary Brady, Cheerio Mahone, Morgan George, and Kevin Robinson. There's the TU Dublin team, which is myself, Hannah, Gary, and Cheerio. Morgan is an architect from Belgium, and Kevin is an engineering student, also from Belgium. So first, as myself, I study physics technology in TU Dublin, and I'm doing an internship with Bernard now as part of the Moon-Mars team. So my role will be the commander and the health and safety officer. And also actually all the crew involved with EMMESI will be the remote support for the EMMESI and IPSA team. So I am mainly focusing on astronaut protocol, daily procedures, communications, and how this affects the well-being of the analog astronauts. This will also be a continuation of Amanda's work on the cognitive function and the use of MOCA tests. So we've luckily learned quite a lot from the Chile campaign and also the previous EMMESI. So hopefully I'll get to continue to apply that. Next we have Hannah, she studies medical physics and bioengineering in TU Dublin. Her role will be crew scientist and engineer. She'll mainly focus on recording the daily life of the astronauts and focus on the in-house experiments, so maybe testing samples and working on the aquaponics experiments. Yeah. Also uses at the moment UV vis spectroscopy, which is mainly focusing on sample analysis, rocks, the minerals and soil components. And this will tie in very well with the previous or current experiments. Next, we have Gary, who studies physics technology, the same as myself. He will be the communications officer for the team. He has a previous degree in industrial and environmental physics, which will definitely come in very handy. He will be focusing on remote operations, so the actual communication between the crew and the remote support, radio telescopes, and everything involved. He's a big interest in technology and building computers, which is coming in very handy. Like I said, he'll be focusing on the communication of data, the objectives, the daily progress, and analysis of solar bursts from the sun with the use of his radio telescope. And next we have, last from Dublin, is Chiryu Mohan, who is also studying physics technology. His role will be engineer and crew support, payload specialist and robotic operations. So at the moment he's working on a rover, which was demonstrated yesterday. Yeah, so it will, I think there's still more experiments we have to align it with on MPOL. So he'll also be working as the REMI rover, the minimal rover, and also handling the Now robot from Bochum, which we hope to use. We'll be focusing on using detectors and sensors within the habitat and looking after the technology. Next we have Morgan George, whose role will be the journalist, so keeping an eye on everything that goes on I guess our daily routines, keeping track for reports. Currently doing a master's in architecture in Belgium, and I will also then focus on the space habitat. So Morgan's individual project will be working again, like I said, the habitat and the architecture within it, the comfort and how it affects the well-being and daily lives of the astronauts. And last but not least, we have Kevin Robinson, who's also from Belgium. He's a physics and mechanical engineering student whose role will be the data officer. His individual project will be in situ production of solar cells aimed to build solar panels inside the habitat and emergency power supply if in the case of a failure. So that is the MPOL 4 team. Yeah, hope you like it.
Okay, so in case you saw some of the Dublin team participants yesterday, because they were really featured into our instrument and mission session, and they are really around. So from the other members, do we have them with us, Morgan, or?
I don't think any other members, unfortunately, are
okay.
here.
So in any case, was a very good and very condensed presentation. We'll put a picture of each of you on your slide when we circulate as well, like the previous team did. Super. Nice first presentation.
Okay.
So
next, we have a presentation from the Leuven team, which will be part of MPOL 5. So there you go.
I think it's a presentation of Alexandra Dobny now. It's the intellectual spacesuit.
I'm happy to speak. I'm just.
Yeah.
Was it not the rest of the MPOL? Okay. Yeah, not a problem then. Let me just.
Yeah. So Axel, you can share your presentation, or I could show the one you have sent to me. What do you prefer?
Alexandra, do you prefer?
Oh, sorry. Yeah, I thought you. You're asking Sarah. I can just share it myself if you'd like.
Yeah, okay,
that's not
fine.
a problem for me.
You can share it and you get an
Okay, I'll just get.
Okay.
Okay, thank you. Let me just share that now then. Okay.
Excellent.
So can everybody see my
yes, very well.
My screen?
Yes.
Fantastic. Okay. So thank you everyone for joining, and thank you for all the incredibly interesting presentations before. So my name's Alexandra Dobney, and I am a law student at the University of Sussex. I'm currently undertaking an internship at the Belgian Nuclear Research Centre. And so my presentation will kind of be in that context. So I'll be introducing some of the aspects of my internship. I'll be briefly talking about the spacesuit and the basic legal issues that are going to be, that would arise in the context of an invention like the spacesuit, with a particular focus on patents. So my internship, because I'm a law student, is more a mix of science and law. So under Professor Sarah Batu and Dr. Bjorn Basselet, I've been helping with coming up with a concept relating to the spacesuit, a way to provide immediate visual cues to astronauts relating to radiation exposure. So that's the scientific aspect. And so because of my legal background, I'm also looking at the different legal issues that might arise in that context. So that's what my internship is about. So the spacesuit, so I'm not a scientist, so I can't tell you much more than just the broad lines of what a spacesuit is. But to put it quite simply, it's a way to provide protection to the astronauts so that they can conduct tasks, outside the spaceship, outside the ISS, outside a moon base, any sort of protected environment in space. So it's to allow them to conduct these activities while staying safe and healthy. So I'm kind of focusing more on the legal aspects of that, which is what most of my presentation will be about. But just before I move on to that, so one of the reasons that we're trying to create a spacesuit that provides immediate visual cues is because space radiation can cause a lot of damage to astronauts. It's something that certainly has to be taken into account when creating such a device. So some of the areas that are the most sensitive when it comes to radiation are areas which you can see on my graph here, on my image here on the left. So you have the eyes, for example, the lungs, the breasts. You have quite a few areas that are especially sensitive, and so you definitely want to protect those because that can lead to health issues, complications in the future. So that's what we're doing for the scientific part. Now, for the basic legal issues that arise in a situation like this, it's important to cover your bases, and to do that, you need to be able to look at an invention like the spacesuit in different ways. So the most important one and the most basic one is to look at the spacesuit as an invention. Now, how does that cover your bases? Well, if you're looking at it as an invention, well, you need to make sure, first of all, that it's protected. So that can mean, for example, a patent, which I will be speaking about later on. But that can also mean non-disclosure agreements. How do you make sure that people are not going to steal the invention? Once you've secured that aspect and you know that people are going to take it and that you can use it safely, then you move on to making sure that it is legal, in the sense that it complies with the relevant regulations. It's safe to use. It's not going to have a negative impact in and of itself that would give rise to actual legal problems. Now, the next way to cover your bases is to look at this invention as something that is going to have an impact on its environment. So it's no longer just an inanimate object. You're also looking at what happens when you place this object in certain situations. So that doesn't necessarily mean placing it in high stress situations. You know, that can be part of the testing to make sure that it's safe to use. But what it mainly means is that you want to make sure that it is not going to have a negative impact on its environment. So you can take that, you know, very literally in the sense of an ecological standpoint. You want to make sure it's not toxic. You want to make sure that it's not going to poison anyone, things like that. You want to make sure that it is safe and that it's not going to have a negative impact. And here again, we're looking at things like complying with regulations, you know. So there as well, you want to keep that in mind. And then finally, to make sure that you've covered all your bases, well, the spacesuit in this particular situation, but most inventions, someone is going to interact with those. So with the spacesuit, you know, you're going to have astronauts that are going to interact with the spacesuit. You're going to have maybe doctors, maybe engineers. You're going to have all sorts of people that are part of the crew that are going to interact with this invention. So if you consider the spacesuit as an invention that's going to be interacted with, here again, you want to make sure it's safe. You want to make sure that it complies with the regulations. So it's important to look at all these aspects in order to make sure that you're not really going to have any problems. And in particular, with considering the spacesuit as an invention to be interacted with, one of the things that's especially important is to make sure that the people who are going to be interacting with it have the proper training, you know, so that nothing goes wrong. And if it does, that they're able to react appropriately and quickly. So that's also an essential part of that. You want to make sure that it's very well regulated and it's safe. That's strange. Oh, yeah, sorry, yes. So as I mentioned, patenting is one of the ways that you protect an invention. So you stop it from being stolen, for example. So what is a patent? Well, to put it quite simply, there's, as you can see on the screen, the World Intellectual Property Office quote. So a patent is an exclusive right granted for an invention, which is a product or process that provides, in general, a new way of doing something or offers a new technical solution to a problem. So it's an exclusive right for an invention, and usually there's some element of novelty, which brings me to my next slide, patent requirements. So I study in the UK, and as part of my course, I mainly look at patents in the UK, in the EU, and in the US. But of course, in the field of space research, you have jurisdictions, you have many more jurisdictions that are incredibly important. But so these are the ones I'm properly familiar with. So they're the only ones I'm going to cover in my presentation. So looking first at the EU requirements. So, well, actually, before we do that, the two jurisdictions, both of them agree that for a patent to be granted, there must be an invention. So that's your core requirement. And this invention in the EU must be susceptible of industrial application and to be used in the industry. It's quite straightforward. And it also needs to be novel. We see this novelty as well in the US. So it needs to be something new. This can mean, for example, that it hasn't been disclosed to the public. So I mentioned having non-disclosure agreements before. You want to make sure that it's not something that's already available to the public. So that's a core requirement for a patent to be granted. Now, the final one in the EU is that it must be an inventive step. And to better understand this, I actually like to compare it to the US requirement of non-obviousness. It makes it a little simpler to understand. What it means essentially is that if you had an expert in the same field who knew just as much information as the person who was filing for the patent, or who was the inventor, provided that they had the same information available, they would not come to the same conclusion as you would have. So that's the non-obvious. It doesn't have to be it can't be an obvious invention. It needs to be inventive. And then just moving on to the US side of things, the invention must be statutory. That basically means it needs to be an invention that can be part of the statutory list for the different inventions that can be patented. And then finally, a patent, the invention must be useful. So that's also quite straightforward. And you can see the sources here below of the legal sources if you're interested in finding out more. So I won't be able to speak much about these final slides because I'm already almost running over time. But as part of my internship, I learned to use the software PatSnap with the help of a colleague. And so here you can see a diagram, a picture that shows the different patents that are available, that have been filed and are currently in use in different jurisdictions relating to the spacesuit. You have a freedom to operate patent mapping, which basically tells you which inventions in the area could potentially be interesting for patents because there aren't any for the time being. And then finally, we have some common terms. That's also part of the report you get when you search certain keywords in PatSnap. So yeah, to conclude, the spacesuit is an essential part of space travel that can always be improved. And when you're looking at these improvements, there's multiple legal issues to consider. And patents can be a very useful tool in this process. And there are still currently several active patents relating to the spacesuit. So I know I'm already over time, so I won't spend too much time thanking everyone. But yeah, really, thank you for all your help. And also, Dana, especially for giving me the opportunity to speak here. So any questions?
Thank you. Thanks very much, Alex, again for a great presentation. To save time, I think there are a few questions maybe in the chat you could answer, but we will continue to go on to who's next. So thanks again. All right. So next is for MPulse 6, we have Agatha and Amanda. If we are here, I don't see Agatha. Okay, I think we might have to continue to move on.
Yes, actually, so MPulse, so Agatha had to leave, but MPulse 3, 4, 5, 6 and 7 will take place in August. So we are planning a campaign from 17th of August, 2 times 1 week. It will be just after the rocket campaign that Agatha has mentioned. And actually, Alex Dobney will be part of this campaign in August, from what I understand. Yeah.
Indeed. And
okay, and whom else is planning from the campaign in August? Do we have a... So yeah, I mean, it's still a bit further in time, but okay, we will figure out. So sorry, that covers MPulse 6 or 7. So we are looking for participants, volunteers there. This crew is not complete. The crew MPulse 3, 4, 5 are very well complete now. So congratulations for connecting with each other. So we are well on track. Now we have 2 presentations of 10-minute max on some of the MPulse investigation prepared by the Leuven group. So let's try all to keep 10 minutes. Yeah, thank you.
Okay, so the next speaker is Dr. Mieke Verslegers, and she's going to explain a little bit what consists the impact of space conditions on the skin and on the brain. So, Mieke, can you share your...
Yes, thank you very much, Sarah. I'm gonna... So, do you see it? Do you see the presentation?
Yes.
Okay, very good. So hello everyone, thank you very much for this very nice opportunity to present this work. I am a scientist at the Belgian Nuclear Research Center, and I'm one of the lead scientists in space research studies in our group. And today I will talk a bit more about our study on the effects of different space flight stressors on the brain and on the skin. So this is a very general slide of what we actually do at SEK. It's not only space research, but it's also other different main pillars where we try to understand the adverse effects of radiation, for instance, non-cancer related to the brain, to the heart, to the intestine and the microbiome, but also how to use ionizing radiation in a better treatment in case of a cancer, also how to go towards personalized medicine, and how to use, for instance, radionuclides for cancer treatment. So the space environment, this is a slide that is maybe not needed to explain to you guys, but we all know that the space is a very hostile environment, and that we have altered gravity, we have ionizing radiation that astronauts are exposed to, but also psychological stress. And this last thing is something that is, if we speak about experimental studies, often neglected and should be taken into account. And this is also what we are trying to do in the lab by performing some ground simulation studies. And so for our altered gravity, we use the random positioning machine to introduce, for example, weightlessness. Ionizing radiation we can of course introduce by exposing them to different types of radiation. And the psychological stress we try to induce by, so in our case, we are studying, we are using an in vitro approach where we are adding cortisol to the medium of our cells of interest. And this cortisol is very important because it's released by the adrenal glands in case of stress, by which afterwards the organism can try to restore, which is a kind of fight or flight response, but can also be maladaptive if you look at it at the site of chronic stress exposure. But our main question here is then to know a bit more about what the individual impact is of these different stressors alone, but also how they could interact, whether it's just an additive effect or whether it's even a synergistic effect, so more than the sum of the two. So first, we focus on the skin. It's quite obvious why the skin, because of course it's our largest organ. It has a lot of very vital functions, barrier functions, our immune defense, thermoregulation, and sensory function that sends signals to our brain. And also, and importantly, it's the most frequent incidents reported by astronauts in the form of small skin injuries, dryness, or itching of the skin. And this is why we want to study it more. I'm gonna go a bit faster through these slides, but the main message here that there are some studies that have been performed in astronauts where they see that the layering of the skin is actually thinner upon space flight, and that there's also a suggestion or a belief that it might be linked to an accelerated aging of the skin. Of course, there are some limitations to these studies. So for instance, this study has been done in 2006, but it was only on one astronaut. So of course, it's difficult to draw conclusions from that. Another experiment was carried out afterwards, which was called the Skin B experiment. Very different results were obtained. They saw not so many things happening than with the study before. However, there were some additional questionnaires, and again, there were repeated reports of rashes, dryness, reddening of the skin, and hypersensitivity of the skin. And very importantly, also they noticed a slower healing of certain wounds in the skin. Yeah. So of course, if you want to know more about what's actually going on, we need more experimental studies. One of them is studies on mice, for which you can see here an example performed in 2015. Again, they saw similar things to what we saw in the astronaut in the previous slide. Also a suggestion of accelerated skin aging, but also an effect on the hair follicle cycle with an increased hair growth, in fact. Then going deeper, you can also do cellular studies, which we are also performing in our lab. And this is an example of the Photon M3 mission, where they sent fibroblasts, so the main cells of the deeper layer of the skin, into space. And there they saw more mechanistically that, as you can see in the picture on the right, that there was more DNA damage in these cells in space when compared to ground conditions, which you can see by the yellow spots. I hope you can see it. And on the left, there is an indication that there is an effect on the inflammatory response, because the bars going to the right side is an increased expression of certain cytokines important for the immune defense in cells in space as compared to ground controls. And this inflammatory response is important because, as you can appreciate from this graph, the inflammation phase of wound healing is the first and most important phase, which will then cascade into healing of the wound. So if there's something wrong with your inflammation, for instance, this wound healing can be impaired, and such an impaired wound healing was indeed found in astronauts. So this inflammation can be a trigger. Also, of course, for long-term space missions, the absence of vital nutrients important for wound healing is a factor. Also, of course, the problems of medical care in future long-term space missions. And then, of course, the fact that there is mechanical stress due to gravitational unloading, which can hamper the regrowth of a wound. So what we are doing, I told you already, we are trying to look at wound healing in space using ground-based simulation studies and looking at the single factors, but also to the interplay of different stressors. And here, I will try to, so as you can see, we made a kind of a scratch into a petri dish. Which grew fibroblasts. So again, the main types of the deep dermal layer of the skin. And after a while, you see that the wound area starts to be occupied again by these fibroblasts, which mimics wound closure. And when we irradiated these cells, we see actually, so that's on the left top, you see that this time to close the wound is not altered upon irradiation, but on the lower hand side, you see that if we incubate these cultures with cortisol, that we have a slower wound healing capacity. And that's really important also to investigate further. Another thing that we noticed is that the cytoskeleton of these cells is changed. This is, for instance, when we put the fibroblasts on the random positioning machine. And when you have an altered cytoskeleton, that's of course one of the reasons why these cells could be hindered in their migration into the wound site. So now we have some quite interesting data about the single stress factors, and our second step, of course, is to combine those and to see whether we have a synergistic or an additive effect in these cells. So that's to be continued, and hopefully we can show you something more if we meet again at another convenience. Now, for the second...
Sorry, it is just a reminder that it has been 10 minutes.
Yeah, okay. Just 1 minute, maybe then I will try to be very fast, because the brain is the second part of the presentation, but actually not so long, because the main results that we did so far in our lab were based on the fibroblasts and not on the brain. Just to show you that also the brain is altered in space, which can have devastating effects on cognition, for instance. And this is mainly characterized by a shift in the gray tissue and also in the cerebral spinal fluid. And here in this slide, I just wanted to point out that it's actually a long-term consequence. So even up to 200 days after a space mission, they see this change in redistribution of the brain matter. Also here, but not going too much into detail, it's not only the gray matter volume, but also the connections between different regions that were shown to be altered upon exposure to space stressors. So again, here our aim is to combine different single stressors and to see kind of interplay. And first results were seen with a random positioning machine and irradiation, which showed actually that there was indeed a synergistic effect, so more than the sum of the single ones in terms of network outgrowth and in terms of cell death. So let me conclude this talk by saying that, of course, we all know that we need a good risk assessment for long-term space missions, and that we need a deeper understanding of the interaction effects of spaceflight stressors. That is possible by doing cellular and molecular studies, as we are doing at SEK, but also importantly, of course, is to translate that first to an animal model, for instance, in mice, and then taking that information to the astronaut that needs to go into space. And it is only, I think, that it is only by knowing the effect of the single stressors that we can also turn into a more directed approach into looking at specific countermeasures for the things that we see. So with that, I would like to end and really like to thank the whole SCK radiobiology team led by Professor Sarah Batou, also by the other lead scientists in space research, Björn Barcelet and Kevin Tabori. And of course, a very big thank you to Eline, my PhD student, and Cynthia, my master student, who did all the work that I presented here today. Then of course, our sponsors and collaborators, and you for your very kind attention. Thank you.
Thank you.
Thank you very much, Micah, for another great presentation. If anyone has questions, just put them in the chat for Micah to read. Okay, next we'll move on. Sarah Batou, if you would like to share your screen.
Yes, my pleasure. So good afternoon, everyone. I don't know if you see my presentation. Okay.
Yep, we can see.
Okay, perfect. So good afternoon, everyone. I'm very pleased to be here. I would like to thank the organizers and Bernard in particular for hosting this wonderful event and giving this opportunity to present our research. So my name is Sarah Batou. I'm heading the group of radiobiology at the Belgian Nuclear Research Center. And what I would like to do in the next 10 minutes is to speak a little bit more into detail about why we need precision medicine for astronauts. We know that we know already for more than 60 years, we have some data about the impact of space missions on human health. But we know that what is coming now are longer mission to the moon, to Mars, and that will have even a bigger impact and higher impact on health as a whole. And what we know also is that this impact can vary quite a lot between astronauts. So it's not that all astronauts always react the same way. And what we are preparing are longer missions, what we call the Deep Space Gateway, which will be the first human spaceship to explore the solar system with the moon and Mars. And one of the showstoppers, one of the main showstoppers was already mentioned by the two presentations of Alexandra Dobny and Dr. Mieke Verslegers, is ionizing radiation. Space effects have got different aspects and impact on astronauts' health, on the sensory motor aspects, on the spine, on the bones, on the cardiovascular, on the muscles, and on sleep. So all these aspects can vary between the different astronauts, and so can be amplified or inexistent in some cases for some astronauts. But there is also, again, a great variability between astronauts. Also, to add to that, we have big differences between females and males. The female body and male body do not react exactly the same way, with some differences that are gender specific. So for the moment, in general, in precision medicine, we speak about one treatment that fits all. So in general, there is a disease, a pathology, and you will get a therapy, and the same therapy will be applied for the people, for the patients or the people who have the same kind of pathology. But the future of medicine, as we know, is really going to more personalized diagnostics and treatments. So based on, amongst others, genetic background. So it's very important to take that into account, this technology, and use these kind of technologies also for the same approach for astronauts for long-term missions. So using high throughput technologies like genomics, transcriptomics, exposomics, metabolomics, proteomics, and so on. When you look here at the cancer risk that astronauts are facing, you see that basically the boxes are quite wide, meaning that there is quite a big variation and uncertainty in terms of risks that is present basically between astronauts. And of course, that this risk will even increase the longer the mission will take place. So when you compare, for example, an ISS mission, you have a slightly higher risk of cancer deaths. And if you go further to the moon or even to Mars, you see that these risks increase very much to a logarithmic scale even. Then about radiation sensitivity, we are not all equal. in front of radiations, and some of us are very sensitive to radiation, some others are very resistant. And we are conducting for the moment at the Belgian Nuclear Research Center some studies really trying to understand and decipher the radiation susceptibility of astronauts and cosmonauts. But as you can see, you have a certain percentage of people that will be quite sensitive to radiation. So it's important to be able to monitor them and to develop the proper countermeasure for that. Radiation sensitivity changes also and varies with age. So the younger age, the most sensitive to radiation, the highest level of sensitivity is amongst the fetus, the embryos and the fetus, and then the sensitivity will decrease with age. So basically, it is important also to take into account for long missions to Mars to send maybe people who are not the youngest ones, but maybe a little bit older, like as you can see on this table, around their 50s. And at SEKCN, the Belgian Nuclear Research Center, we're studying basically the impact of radiation on different aspects, developing biomarkers of radiation susceptibilities, testing different types of radioprotectants in order to give before an EVA, before an extravehicular activity, in the course or during the course of the mission, in case a person start to develop different types of radiation sensitivity patterns. We also study the impact of cosmic radiation and space in general on the brain, as was shown by Dr. Mieke Verslegers, on the microbiome. So how can we, by improving the quality of the microbiome, which is the population of bacteria that we have inside the guts, how can we improve the health and the resistance of astronauts? We're also studying the cardiovascular risks, the impact of space conditions on skin and on the immune system. Some very small slides just to give you a snapshot of what we are doing. So this is pictures to show you the monitoring that we are performing before and after flight on the ISS for the moment, for the past 5 years, on astronauts and cosmonauts, where we get blood before the astronauts are going to the ISS and when they come back. And that really helps us to determine the radiation susceptibility of each astronaut. These experiments was already shown by Dr. Mieke Verslegers, so I'm not going to go into the detail, but this is another space experiments that we sent to space on the ISS to study the impact of endothelial cells, which are blood vessel cells. Very important because these blood vessels are usually very sensitive to radiation. When we are talking about missions to the moon, to Mars, we have also to take into account the spacesuit that was already mentioned by the student Alexandra Dobny. And we are talking there about 70 EVA, extravehicular activities outside the moon village. So this spacesuit needs to be quite resistant and quite protective towards all the different extreme environments on the surface of the moon. So for that, we are working on different types of shielding and different type of monitoring and sensor. But the most important is really developing biomarkers for precision medicine in astronauts in order to help them the best we can in terms of developing and advising in them in terms of the number of extravehicular activities that they could do on the moon, on the basis of the moon. And these biomarkers are of different categories. Usually they are molecular biomarkers, transcriptomic. And we're also working on different ways of improving radiation resistance of astronauts by enhancing shielding, by medical selection of radio-resistant individuals, by testing radioprotectants, by developing biomarkers, by decreasing the metabolism, or by developing regenerative technologies. So in conclusion, better personalized risk assessment is really important and necessary for deep space exploration, and that we need more insights into the possible interaction of the effects of spaceflight stressors in order to reveal altered cellular functioning. So let's not forget, by the end, that space research benefits to the patients and allows really to increase and improve medicine, to improve the diagnostic, to improve the treatment. So there is really a huge benefit on Earth. And with that, I would like to invite, if you want, as a student, to join SEK-CEN, to come for a stage, for an internship. You are more than welcome. Just contact us, and I would like to thank all my collaborators and thank the organizers of this conference. So ready for questions if we have any time. Thank you very much.
Super, amazing. Yeah, so let's get the question on the chat, and after we will have also opportunity to have a follow-up session, maybe a splinter, after we have concluded the main session. Yeah, so okay.
Thank you very much. Okay, next we have Karoli with the presentation. Are you here? Yeah. If you would like to share your screen.
Can you hear me well?
Yeah.
Excellent. Right, so I'm here to talk to you about a recent startup we have started in 2018, and it's since been incubated by the Business Incubation Center of the European Space Agency. We are called Aquanauta Center for Exploration, and the idea stems from some of the research we have done in multiple different analog research sites around the globe, also including in LunarES. And one problem, as I'm a behavioral scientist, and one problem I have come across that these venues are very helpful to mimic different kind of activities in relation to space exploration. But in terms of behavioral science and behavioral health, the data I was able to derive from these venues was questionable in terms of validity and reliability. And as Sarah expressed just in the previous presentation, precision medicine will be very important in the upcoming years in space exploration. With the very small sample sizes of 1 people at a time, or maybe 6 people at a time, it's very difficult to drain knowledge and data which can inform us about key outcomes in relation to long duration missions and spaceflight. So after working on a project at the European Space Agency in Cologne, I have become familiar with these interesting facilities in ESA, the Natural Buoyancy Facility, and as well as the NEMO and the CAVES mission run in joint collaborations across different organizations, including ESA. And I guess one problem the reason why we think that the behavioral data obtained from lower mid-fidelity analogs is problematic because they do not impose much threat on the participant. Isolation, confinement, and other low fidelity features of missions are not always intact or in place, typically in low fidelity missions. In mid-fidelity missions, there are some threats involved, but again, the magnitude of that threat is not substantial to sort of the crew members need to think twice before what they do. And then high-level features would include things like altitude depth, dark and lightness, and light cycles. This is from our lead research scientist's work, Ilaria Sinelli. So we tried to come up with a concept which can help us to, first of all, create a large number of data entry points over time, and where we can replicate missions and studies. So we have identified a number of venues across Europe, as well as now in the world, which would be suitable underground venues to conduct their experiments. And the exciting part about this is that we have here a tunnel, which functions as the habitat, but from the habitat we have different natural underground tunnels, which are also underwater. These are really exciting because they help us to mimic, and this is what it looks like in real life. They help us to mimic extravehicular activities in a confined, isolated space. And, you know, if you run out of time and, well, oxygen, really, your time is out. And you really need to carefully plan ahead to conduct your dive hike, basically. Carry out different missions. If you watch carefully, you can see it that at the water scooter, the diver at one point steers up the sediment at the bottom of the cave. So there are a number of things one need to take into account while diving and exploring the caves downstairs. And one mistake can lead to a lot of complications. That having said, we work with some expert cave divers across Europe and the world. They're all experienced in what they do. And our objective with them, and as well as with scientists from the space exploration industry, is to create a state-of-the-art context, which can be a high fidelity version of terrestrial space exploration. And in this context, we are focusing on different human factor data, human factor disciplines, including psychology, physiology, neuroscience, medicine, biology, and as well as geology, and ergonomics, to identify the right means of working in these harsh and extreme contexts. We hope that once we are able to carry out multiple missions, we can create data which is actually valid, reliable, and can meaningfully be transferred into space exploration. And the people we work with, expert cave divers, experts in space exploration and research centers across Europe at the moment mainly, help us to develop our concept and the mission concept and design, and perform different scientific activities which can then further our knowledge, either in cave diving and extreme diving, as well as in space exploration. We are looking for investors, business partners, industrial collaborators, also divers and researchers who may be interested to take part in our work and contribute to it. In the IAC 2020, we published some of our rationale and some of our work we've been doing. And I would be happy to answer any of your questions, should you have some, either here or in the chat box. Thank you very much for your attention.
Okay, thank you. Yeah, so clearly there is a lot of ground to work together. So welcome to the Jeroen Mars Astronautics Training Academy. There is really some good place where we could find synergy with your efforts. So I propose that after we finish the session, we could have some splinter discussion with all of us, because we have a sharing similar interest. So let's move to the next talk with Shoma Berkemeya on
Thank you. I think you can see my presentation. I just have to go into the full modus. Right, I'm a nutritionist, and Bernard asked me to speak on nutrition here. I'm not presenting any personal or original work, rather brought together the core crux of the nutritional research that I would be targeting in the near future, and thus I'm looking very forward to your collaborations and certain ideas as well. I've called it Nutrition Earth, Moon and Mars because that kind of sums up the ethos of this particular talk series, workshop series, but as well as how much research has actually to date taken place. What we see here is, I love the mythologies, we can always begin there. There's Gaia, that's Earth, and in the F2 generation of Earth, we find Moon as in Selene, more known as in the Nordic way, classical Greek, when we tend to say more Diana. So F2 generations of Earth, that's Moon, and we see that as well. There was a moon landing initial in 1959, humans on Moon 1969, as well as the far side of the Moon as recent as 2 years ago. F4 generations, so what fourth generation from Earth, we see we're now talking in terms of Mars, and that's where a certain amount of excitement is going on even in this group. So that's actually how it looks like. We've got the Earth, the blue planet, the red planet, and a rather cold gray moon, and we are kind of oscillating in this spheres. And on Earth, our moon and Mars look very much like what you see on this screen as a nutritionist with our food. And here you got moon trees and you got Mars, and maybe you ought to be happy. The fact is, do we get all that, all those goodies? How does it look like in space, and what bearings does it have on the human body? As a nutritionist, I've just taken out the element selenium. It's a trace mineral which we as humans require. There are actually for every component, nutrient, we can go into great details, but because it is selenium, comes from the word selena, moon, and that's why I'm presenting about on selenium. It's a chemical element, 34 atomic number. It's a non-metal, and it's a trace element essentially required for humans. And we see why it's required. It's required to make DNA, prevent cell damage. We've heard lots of that from Professor Batu, and even the Verslegers. She made it very apparent why we require all these nutrients. And we have a current requirement about 50 micrograms. You see, it's very low what we really require, but if you wouldn't have it, it leads to trouble in the sense of deficiency of it. We're having nausea, vomiting, lethargy. And look at it, if you're going in the toxic range, it's still looking somewhat similar. We still have a bit of nausea, vomiting, and fatigue, irritability. Like that, I could expand and extend on perhaps every nutrient, and that becomes important on Earth, but as much, just as much in space, meaning we're in the human factors on Moon and on space. Our current knowledge, getting it all together, 3 kinds of food. This is rehydratable, thermostabilized, and in natural forms. Natural form of food in space is a luxury. Essentially, we're getting actually dried nuts and fruits. I won't take too much time just to get the matter couched within the nutrition. That's why I'm just going through it. If you talk of food culture, we're all human beings. At the end of the day, we come with a certain background, and current space food looks like half of them is for the astronauts, the other half has been made for cosmonauts. There was a question, do we in Europe, do we require to develop some new foods for space? I'm open to ideas. Food challenges in space, crumbs are not allowed. When we eat, we have a lot of crumbs. I'm a classical guy who makes a lot of crumbs all around me when I'm eating. Not pretty sloppy about that. But that's a problem in space because it can get into ventiles. That's a technical part of it, but even in the human spacesuits, etc., it's a big issue. Second issue is the waste has to be compact. It's once a month that a vehicle goes and picks up all the waste products from space. There are freezers or fridges, the latest one, Merlin. And then what, of course, has a big bearing on food and how much we want to eat and what we want to eat, the taste, the texture of food, which is very much altered in space, how we appreciate or how we feel food. People tend to like, or astronauts and cosmonauts tend to like spicier, as per the current research, and apparently the space shrimp cocktail is the hit, and of late we've even got something like tortillas. Thus, keeping food tasty, nutritious, and easy to prepare, it's quite a challenge in space. The kind of research questions that are kind of conglomerated in the field of nutrition. Per se, how is human physiology and biochemistry looking in space as a product or as a function of food and what we're eating? How is the human body utilizing them? How to collect human samples of blood and urine in order to get information how the human body is functioning? and a certain information that the astronauts and the cosmonauts, they get trained actually even for drawing their own blood for all the nutritional experiments. Much of the nutritional experiments are not really happening in space, they're happening on Earth, but the cosmonauts and the astronauts, they're drawing their own blood and samples. And why do we need a balanced diet? For not much any other reason as what we require on Earth. We need to remain healthy. As a result, we need to be productive or serving the purpose of being productive. So the methods as of now of data gathering, astronauts, they collected blood or they collect blood and urine samples which are analyzed on Earth. They are also undergoing what's known as functional tests. There are exercise machines, etc. Spirometry. You can analyze the crew members' muscle, bones, vitamins and minerals, which is very interesting for a nutritionist. And the knowledge from the International Space Station is now being used now for the future missions on Moon and onto Mars. Now I come to certain studies. They're very long-term studies. The very first study, it's almost 10 or 12 years old when I did my PhD, and it's still going on. I mean, I was briefly involved with, not really directly involved on the outskirts of this study, but the protein potassium study. What you see as Pro and K is a chemical name for potassium, protein potassium. The basic hypothesis is that the diet with low ratio of animal protein to potassium would lead to a lower loss of a bone mineral in flight and in space. The results, my God, they're still awaited. It goes on till 2027, 2028. You can imagine if it's 10 or 12 years already old. Anybody interested, get onto that link, NASA government, you get the details. I personally am highly interested in the results, being an acid-base expert myself. And this will be kind of the studies which I want to now augur in my in the university that I'm currently at. There's another major study which goes on stability, stability of nutrients now, not at the human level, but at the nutrient level. Does nutrient breakdown occur in food stored over very long time faster in space as compared to Earth? And there is what we did is, or what has been done is salmon, almonds, broccoli and cheese, they have been set up in space and they were controlled samples on Earth. And they checked how were the nutrients after an X period of time. Now, what the good news is that the space storage did not really cause a faster breakdown of nutrients than on Earth, but irrespective of space or on Earth, there is nutrient breakdown after a while. So we got a problem. Because yes, now we have a 9 months period max. Mars would definitely mean far longer. How do you keep the food nutritious? Because at the end of the day, you just don't want to eat something. You want to eat something that keeps you functioning. The third...
Wait, Shoma, sorry, but the 10 minutes is up. Maybe a minute left.
So, sorry, I didn't get you, Kevin.
Just to say 10 minutes has passed.
10 minutes has passed. Bed rest, just give me a minute. There were bed rest studies to be talking of. Other studies involving vitamin D and antioxidants. Based on closed ecological systems, the challenges is going to be between closed ecological systems and living off the land, creating moon soil with fungi, getting the asteroids and making soil out of them. That's a challenge which we need to consider in terms of nutrition. I'll skip this slide. This last slide, I want to bring it in context, what I've just spoke about. That was about protein and potassium ratios, acid-base balance. Now you see, protein, what we need in space is far more than what you need on Earth. Total calorie requirement is less, 20% less. I would be starting some pilot studies in this area. And as a component of that, on Earth, we just require 0.9 kilograms protein per body weight, kg body weight. In space, that increases to 1.4. So that's an area that is pretty much exciting to research for the near future. I rest on that. I'm looking forward to collaborations and ideas to how to do ground-based simulation studies and altered gravity, since I'm setting up my own lab currently. Thank you. That would be. I'm done. I wanted to talk about Matt Damon, but you didn't let me talk.
Thank you very much for another great presentation. If anyone has questions, just put them in the chat and Shoma can answer them. Okay, so moving on, we have Nancy Vermeulen from EMMESI Astronaut Training Academy. you'd like to share your screen.
Hi, so I think Nancy is here, but I guess I'll present the first couple slides. I don't see Nancy at this point, so. All right, hi everyone, thanks for organizing first of all, and thanks for the very interesting talks. So we are talking about EMMATA. This is the Earth, Moon, Mars Astronautics Training Academy, which is being founded, I mean, and you know, we want to present to you how far we are at this point, what we are offering. So, first of all, what's our inspiration? We are inspired by the Earth, and more importantly, what's in orbit around the Earth, for example. So the ISS is an inspiration to us. The collaboration between the different countries. The Moon is also an inspiration to us, and the villages, the research we're going to do on the Moon. And finally, Mars, and of course the other planets, the other things to explore in the solar system is an inspiration for us. So what is our vision? We want to make space know-how available to everyone. So it doesn't matter what is your background, whether you have a master's, a PhD, or if you don't have that, if you are already advanced in your career, or if you are still a student, we think space is for everyone, and we want to make the content. So not just the know, so the theory, but also the know-how, so the practical, available to you and accessible. So what are the pillars? We offer 4 pillars: science and engineering, humanities and social science, management and business, and practical astronautics. So let's look at those pillars. So first we have science and engineering. So what we're doing now is to present a person who is offering something in our academy, and then what this person is offering. So in the interest of time, I don't know if we have time for everyone to introduce themselves, which was my plan. And I think everybody knows Bernard. So Bernard has a fantastic career. I only put a couple bullet points, obviously, because they wouldn't fit in one or several slides. So I just put a very, very brief summary here. But what I'm, I think, most impressed with Bernard is that he was the PI for Smart 1, which is the first and to date only real European mission around the moon. And I think this is really remarkable and something that cannot be overstated. So Bernard is always glad to teach science theory, but also perform a lot of scientific experiments. So this is the tag we have on Bernard at the Academy. Bernard is also the head of the Academy, well, the academics, but will help with deliver the scientific experiment and training. We have Sarah Batu, who just spoke a couple of minutes ago. She's also a very impressive head of radiobiology at the Belgian Nuclear Research Center. A lot of other great stuff that she's doing. So I cannot go into detail for each person. I'm just saying this is someone fantastic, and she's offering space biology. So both particle stuff, experiment in labs, also remote experiments, and also a lot of theory. Notably, the first point is biology introduction. So that's for beginners. You don't have to know biology before you can take courses here. You can do the beginner's course and then go into more advanced if you're interested. So this is, I think, fantastic. Moving on, we have Sylvester, who is a robotics and a AI and machine learning expert. So this guy is also incredible. He has a bunch of jobs at the same time. So he's CTO in 3 different companies, in robotics, AI, and other space companies. He works at the same time at ESA and at NASA and at other companies. So he's a great guy, and he's very eager to teach robotics. So that's going to be his topic. He's going to be teaching robotics theory and hands-on stuff. And at this point, he's designing the course and wondering what students actually want to learn, and whether they want to spend more time on theory or on practical stuff. All right, so that was science and engineering. Now we're looking at humanities and social sciences. So we have Michael, who is leading humanities. He is a senior lecturer in Protestant theology at the University of Bochum. Well, as I said, I will go quickly. Elke is also, well, she's leading social sciences. She's a professor of sociology at the same University of Bochum. And together they are teaching humanities and social science. And so what you can see here, what they want to do, research on interdisciplinary cooperation between science and engineering and humanities and social sciences in the space sector. So, you know, I think this is very inspiring to be able to look at not just the technical part, but also like take a step back and understand what is the implication for humans. That's a fantastic department, I think. We also have Borgildor. I don't know if she's here. No. Indrida from Iceland. Is she here? Well, if you want to say something, of course, unmute yourself. So she's an artist and an architect and has a master's in architecture. She's the director of art, and you know, she's the person taking care of the logos and all the stuff for the school. But she will also, I think, participate in delivering some arts contents. So we have management and business, and that is also very, I think, interesting and useful. When you come from a technical or a science background, you don't necessarily have, you know, management and business perspectives, which I think in like today is super important to have, at least as a bit of a background. Otherwise, it's very hard to progress in your projects, in your career, and for your company and things like that. So might come up some of a surprise for some of you guys. That's a new recruit. We have Mathieu Richard, who works at Intelsat, and he's been working as sales, product marketing, corporate strategy, but also at Airbus in business development and government communications. So he will be teaching, well, strategy. And we have Alban Soreda, who is working at Air France, but also worked at Airbus before and Thales. And he is, well, you know, an expert in key account management, sales, supply chain, and things like that. And he can deliver classes in negotiations and in product management, which I think is very important. So that's sort of the three courses we have in management and business: project management, negotiation, strategy, and business development from a SATCOM perspective. And we'll be expanding this as we get more professors. Okay, now number 4, and I'm trying to be as quick as I can. That's the practical pillar, which I think is very interesting. So we have Nancy. Nancy, do you want to present yourself? I think you're here. I don't hear Nancy.
I think she might have left.
Okay, then. Well, I will cover Nancy then. Well, Nancy is also an incredible person. She has done, like, I think everything in her life. She's an astrophysicist, but also an airline captain, a flight instructor for airlines, not just, you know, private pilots. And she's also a private astronaut trainer. So what she's offering is 2 main things. The first thing is zero-G flights through TU Delft. So, you know, if you're interested in this, you can do that through us. The other thing is, oh, that, by the way, this was Nancy here with the blue suit. And she's also delivering actual astronautics training. So what you see on the left side is not a standard centrifuge, which you have in the middle. The one on the left is actually a space flight simulator. I think they simulate a Soyuz capsule. They have 2 options, I think. So you have the actual Soyuz panel, and they can replicate any trajectory, you know, and whatever you do will affect what you feel. So it's an actual spaceflight simulator. I think they can simulate dockings as well and things like that. And on the right side, a hyperbaric chamber. Okay, next we have Agata, who is also a fantastic person, astrobiologist. She co-founded 2 habitats in Poland. So that's for analog missions. And she's doing like a lot of stuff. You have to look into what she's doing because it's crazy. And what she can offer is space in practice. So she has analog missions, rocket workshops, also hyperbaric cognitive training, but they also do skydiving, microgravity projects, and stratospheric missions. So there's a complete set of activities, and that's all based in Poland. And next we have Matt, who is also based at the same place in Poland, a space engineer who worked at ESA. And they work together basically with Agata, but he's the diving instructor and a pilot instructor. So he's focusing on diving and AI. So diving trainings, but also Python and machine learning courses, AI control systems for space applications. Okay, then we have Mark, who is an exogeologist. He studied at VU Amsterdam and ISU, and he's an analog astronaut, but he's also managing the chill ice analog. And so that's when we look into the analog missions that you can do through EMMESI. So we have the high seas, which is in Hawaii. We have the one in Chile, and we also have the one in Iceland, which is chill ice. And hopefully there will be more coming soon. Now, myself, Julian, I'm a commercial pilot and a flight instructor, but I also work on startups that do satellite and, well, orbital mechanics, really. And I've been working 10 years in business as well. So what I'm offering is flight training. So all the way from just a few hours of training to get a basic feel to an actual private pilot license. That's taking place in Paris. And I also teach orbital mechanics, but not from a theoretical perspective, which can take like tens and tens of hours, and then you still don't get it, but from an actual practical perspective. And as you can see on the top right, this is very, very true. Like you can take high school physics, get a physics degree, work at NASA, and still don't understand what the hell is going on with orbital mechanics. But the second you use this software, which people call it a game, KSP, it's a game, Kerbal Space Program, but it's more of a simulation than a game. They try to gamify the simulation. So that's what I'm going to use to teach anyone who's interested how orbital mechanics work. And I think after just 2 days, you really get it and you can talk to scientists about what's going on. All right, so how can you be involved? And I hope this is less than 10 minutes. We're looking for professors and trainers in all the fields we mentioned, but also other fields. That includes management and business, where we're looking especially for more people. We want teaching assistants and we want program participants. So if you're interested in learning stuff or teaching stuff, then get in touch with us. This is our temporary email address, emmata@themoon.is. And that's it. Thank you very much. Let me know if you have any questions.
Thank you very much, Julian. I know I'm definitely looking forward to hopefully being a student of EMMESI and I guess getting to learn everything involved with spaceflight. And like before, if anyone has any questions, please put them in the chat.
Yeah. And I have another meeting right now, unfortunately, so I'll have to leave. But...
Okay, so great overview, Julien. And I think that, okay, we had planned more time for you because so you have your presentation. And so we could have some 10 more minutes to collect questions or requests from our team. We have to say that de facto, all the participants to this workshop, they are members of EMMESI because some of the material presentation or lecture that we have given, this is a kind of a first basic 101 of what we are doing. So those of you that followed the lecture and we took note of who was there at a different day, we will eventually use that also as a kind of a pre-knowledge in the build-up of our astronautics academy. So I think that Julien, you made a very good overview of the goals and of the team. And of course, we are also looking at some more students, but also teaching assistants. And I believe that there are many areas where some of us can learn. So I'm going to follow the courses of Sarah in some area of space biology, some other in management, even if I can teach space science and technology. So we can be both students, we can both be the teacher, and we can learn from each other. And as well, I'm looking to do some of this practical training in some activities that you mentioned. So it's really an academy where you have academicians from, let's say, yes, from a teenager to 70 years or beyond. So that's, I'm also part of the International Academy of Astronautics, which is more the 70 years age average, but I think it's very important as well to get some of the young workforce. Also those that will be full-fledged astronauts in theory, in practice, and in flying in orbit and beyond. So I think that Julien, so very great work. We look also to collaborate with some of our partners, for instance, institution like EPSA, that represented here with Roxana. She is teaching some of the students that could really benefit from our courses. Also, we developed some of this training in simulations that we have done with Your Moon Mars, and this will be integrated in some of the curriculum also that we will offer in the EMATA Academy. So, Roxana, you want to make some comment on how it fits with some of the goal of your students?
No, I think I'm gonna start promoting EMATA for my students. And yeah, I was smiling when you presented KSP, because I want to do that too in my space mechanics and my orbital mechanics classes. So yeah, it's a very good tool. Yeah, it's a very good tool for them to understand how does it work.
Mm-hmm. So what is the next step, Julien, for some of us to be more engaged? And are there some projects? So, okay, we had this innovation workshop. It was also to look at some of the participants. So in the next weeks, next months, are there other milestones that you're looking for the broad Your Moon Mars community to participate?
Sure. Well, first of all, there will be the GLEX conference. Later on, there will be the IEC conference. So we want to be active in these conferences. Then there's the usual workshops that you always organize. So that's considered part of EMATA for the practical activities. And then, so some people ask me, how can they read more about the project? So we're working on building a website to describe what I presented to you today. That's one of the activities we're working on. And, at some point, once we gain enough traction, we'll actually start doing some courses. For example, Sarah is eager to teach space biology. And so we need to gather up students to create classes for Sarah to teach to them. So we are basically trying to gather interest from students, from professors, and from TAs, so we can build this thing up.
So now, also, I say we have organized this workshop, and I think that, okay, we had special conditions with restrictions so that limited the physical presence, but we have advertised it. So also on the YouTube platform, on the Zoom, I think that we could have had more audience. So we should use some of these materials that we have recorded. These are like a recorded lecture, and after some edit, we could make it available, and these are some of the, information material that is relevant for the academy. And I would say also it's very important, if you are part of the academy, that you make the effort to listen to other topics than your own. So I've seen, some people came up, they came to give the lecture, and then they left. In academy, we have really to have a good crosstalks. And so we have also to make the effort, to make the time to look at what the others are doing, because we are going to learn. So that's also part of being the academy. Also, we are going to have this ample campaign. So the next one will have 18 crew astronauts and mission support. And I believe that we should also structure that so that we fix some training objectives to them, and we could validate, because we know they're here. And I have the example here of my Dublin interns. They have been amazing in doing many tasks, mission support. They have run this workshop here, solving a technical problem, sharing session, and so on. So we could really, for the ample crew, also have some training objectives for all of the participants, and give them a beautiful certificate already for this workshop, but also for the ample and for each of the campaigns that we are going to conduct. a bit like pilot project of some of the building block of the academy. As you mentioned, Julien, we have to start pragmatic with some specific block where we are good, where we have already some of the material, like switchy material, like Sarah will give, like I can give for space science and so on. And we can really show how useful it is. But it's important also to find a scheme where people can participate. So not always in real time. So eventually sometime some material that is put online and that is made available to accommodate those that cannot always be available, you know, during daytime or others. So like any from student perspective, Kevin, what do you think? So as a student, how would you benefit for such academy?
Yeah, no, I'm definitely very interested in, to be honest, all aspects of what EMMESI, I guess, are doing. Even just the chance to participate as a student or a TA, I'd be delighted to, because it's all, I guess, doing an internship with Bernard, it's about building our experience and learning more at the end of the day. So any part of it, from the technical side to the business management as astrobiology, I'd definitely like to at least participate and see what I can learn. So from my side of things, yeah, no, definitely sounds like a great opportunity.
I like also the virtual experience of networking. So now we do it a lot virtual, and we will have some opportunity, like we had for the first time here in 1 year, to meet in person with some of the colleagues. Thanks, Fabian, for hosting us and allowing to do that. And progressively, we will have this opportunity to return to Toulouse. Like Roxana hosted an event there. We will go also to Leuven. We will start to go to places. We will meet in Poland. We will have a big workshop. Also, we will have Iceland, partly to present, or at least so we live in a connection where we do things together, we learn, we train ourselves all together. And this year, I think, yes, we are going to, it's good to invest in some of the remote connection, so that when we meet, we can do something very effective.
Okay, I guess, Bernard, do you want to talk about the astronaut selection?
Yes, so yeah, we had planned a kind of discussion slot about the call for ESA astronauts. And so clearly based on our experience, we have some information of how we could help some of you that want to apply for this ESA call for astronauts. So we can give you some details. There is also in parallel another call for astronauts that you may have seen, a call for Dear Moon. Who has applied to be on board Dear Moon, to fly to the moon? Yes? Well, yeah, so I think the deadline was yesterday or something like that. So we are now in the second phase, where we have to give some details. Now on this one, it looks like it's really a PR campaign at the moment. So it's collecting candidates from different countries that are bringing also with them a big community of followers. But I think we may also help you into this in giving you as well a profile of somebody which is already into space, that knows the moon, and that could be useful on this expedition going around the moon. So that's a way actually how I'm going to profile myself. So I have the maps, I know where to go, what to look at, and I can entertain you. In a few cases, I was invited to join some cruises where I was asked to be the astronomer on duty, talking about the moon and the stars. So I can do that when we go there. And so we are going, thanks to the EMMESI Academy, give you some of this background as well. So any of you can be invited on a sailing cruise, on a boat cruise, or in a Nile cruise to speak about Moon, Mars, space, and so on. So that's one way we can help you to boost your profile. Another way to boost our profile is to multiply our community. So then create a pool where all your individual followers can also follow the other members of the Moon, Mars, and EMMETA community. And build a good group. We have also some clever guys that are able to have some tens of or hundreds of thousands of robotic followers. So they create some bots that and I think that all of you deserve to have at least 100,000 followers. From what I have seen, what you are doing is great, more than some celebrities which have more than that. So I think you deserve. So eventually, we have a good AI colleagues here in the group. They could really train some bots in the community that spread, create some nice followers, and this may inspire the crowd, the real people to come in. So I don't mind if I have 10,000 robotic followers that we can bring 10,000 real ones. That should be a good strategy. And so that's one way. So for this dear Moon, is Mr. Dear Moon with us? We should not unveil all our trick. I have to say I played a little trick for Dear Moon because I have the feeling he's looking for 7 candidates. Is that it? 7 candidates. Initially, he said that 8. He was looking for his girlfriend. So then Elon Musk was not really keen on that. So you're not, and so now he's looking for people from different countries. I believe from the numbers. Some of you, do you have your picture with your Dear Moon profile? Mary, you have one if you want to post it. Oh yeah, you can post it on the screen or any of you.
Yeah, I'll have a look.
And they count the number of participants per country, and they have also some overall numbers. I think that he has nearly reached 1 million.
Yeah, he has a lot.
And some good number from the Netherlands. There's some 10,000 from Spain. And so when I had to fill the country, I said, well, I'm not going to be one of 50,000 French. So I put Antarctica.
Can you see it? Or
and when I feel Antarctica, because I think that it's also a precursor to the moon base. The moon base is, and I'm planning to go to Antarctica next year. Yeah, okay, you see Mary, she has a suit. And when I registered, there were only 4 people from Antarctica. So I hope to be one of the Antarctica. And as you know, at the end of this year, in December, there is a solar eclipse, which is visible from Antarctica. So hopefully I can, at that time, we really have a good experience. So that's for the Dear Moon.
This is better.
Yes. So let's say you see Mary, you can talk at the same time, then you can see big. Yeah. Mary, country Netherlands. What number are you? Can you show the other side?
Well, it's in the.
Oh, you
I have from, number. I have number 6012, and then the next one is 690,000.
690,000.
Yep.
Okay. So good luck, Mary. Because initially, he was mentioning that he wanted to fly with 7 other artists.
Yeah, he was mentioning artists.
You know, I studied science and technology, and I thought, okay, and the moon, and I said, this would be a way to go to the moon. But I figured out that maybe artists would have been a better career to go to the moon, to go with Yuzawa. Okay, so Mary, good luck.
Young girls.
So that's for the Dear Moon. Any other question on Dear Moon? I think we should also use the Dear Moon campaign. You know, he was able to really to raise the interest of 1 million people. Eventually also to advertise what we do. So to say that and I know the Art Moon Mars group, they have also encouraged all the artists of the Moon Gallery to be on this Dear Moon campaign. So we could eventually surf a bit on this of this wave of Dear Moon to show that yeah, what we do. And in any case, we know the moon more than many Americans. So yeah, so let's use the Dear Moon wave. Now, on a more serious aspect, there's this call for ESA astronauts. So are there some questions from some of you about this call, or should we summarize what is the situation? So ESA I just, you know, in 2008, conducted a call for ESA astronauts, and then they selected a list of 6 and a few reserved on a waiting list. Initially, there were also 2 ladies part of it, but one dropped out, Marianne from Belgium, and only Samantha Cristofori was left as a lady astronaut. And so you see, and they it was more than 11 years ago. And so ESA has announced that we are going to make a call. So it will be formally opening on the 31st of March. And we will have about 2 months to answer. And so it's it's described that we are targeting to have typically, they didn't say exact number, but maybe the same number of ESA paid astronauts. And so this would be around 6. But we have also included a new category, which we would call reserve astronauts. And this could be people paid by their own company. They continue their work, but they would have a status that would allow them to do some of the training and so on, and be possible reserve astronauts. And there could be 20 of them. And so if you, so that means that we will have to train a larger number, even if we don't pay all of them. But then there are ways also to get, for instance, some engagement of some of the countries of these reserve astronauts, some of the companies of these reserve astronauts, or some sponsors for some of the flight. And this could be a good opportunity for some of you. Now, at the moment, we have set some rules, I mean, some guidelines, they're not rules. We have to see the exact code, which will go out on 31st of March, that we are looking at candidates which have a profile of master, you need to have a master, plus 3 years experience. So that's something new. In the last call, some applied with just right after a master. We have to see also if some of you which have just a recent master, but have also other type of experience that they have acquired before the master, you could try to justify that you have this master plus 3, in the sense that you have done 3 plus master. And so, in any case, we had more than 9,000 candidates in 2008. It's likely we will have more candidates. So what is interesting in this exercise is we need to go through the steps and to use this code also as a way to learn about yourself, about what you are interested in, to get through this experience, even as a candidate, and to see also in your curriculum, in your career plan, what other areas you would like to develop, for instance, to address some of these topics that astronauts are covering. And I think it's a good practice. They mentioned that age above 50 it will not be a big positive factor. So I'm out. But okay, maybe I'll apply still, just to know about the procedure, like I did in my youth. I applied and I finished 53. So in the selection. For instance, I got some good grades at that time. because I was living at 3,000 meters at the European Southern Observatory, and I had done experiment in caves of isolation, so this gave me some good. And so the experiment that you do in simulation campaign, this can be used in your favor, so we can help you also to describe how this is relevant for the call for astronauts. So any candidates, open candidates, do we have some in the room? I think that Roxana, yes, we want to. Sarah, you should apply. Yes. Okay, I see. I believe also, I mean, others, Mary, you should apply. Yeah. Okay. Any here from this group? Yes. Okay. So we should identify, some of our, how do you say, those candidates that we are going to bet on to win. Huh? So Charlotte, yes, when you apply, we want to support you. We run a campaign. Now I believe that, of course, this is a very limited set. This is a call, but what Julien has mentioned, this is also can open the way for you to see how to go to something which is more realistic, which is to become a suborbital commercial astronaut. Because that's something that is really in the range where us, our community, I believe, can achieve relatively, I mean, with some work, with some co-funding, but in a natural way. And as you know, there are a number of commercial spaceflight opportunities. You can buy your ticket to become a suborbital astronaut. So you get a 15-minute flight, some 5 minutes of 0G, and you fly above the 100-kilometer Kármán line, so you are cool astronauts. And that's a problem we have because of this glamour of astronauts. So you have all the celebrities and rich people that are going to do it before us, and they are going to buy the ticket, and then we will have possibly 1,000 new astronauts, celebrities. But at some stage, there is a niche right after them for us, where we can say, we have some research experiment we would like to fly, and we need to have a 0G for 5 minutes. And so with the support of our universities or research institution, you can write a grant, and you can then apply for funding for your experiment. So let's say 400,000 euro, 200,000 to pay for the flight of the astronaut to operate your experiment, 200 to pay for your experiment. And at the time when you have to select who is going to run your experiment, you can select yourself because you are the one that knows best your experiment. So that's a scheme that we could easily help you to implement and become really this research astronaut. And so I think within a few years, I think that there is really a niche for us, and the EMATA Academy comes really at the right time for that. So any question on that? Yeah. Yeah, I mean, yeah, on one hand, it will be very similar. Some top, like top professional, very motivated to be astronaut as well. So in the past, we had a number of pilots. So they had also this called so self-discipline and organization that we could rely on them. But we are going also to open it to so-called payload specialists. So people with scientific or engineering profile that are able to operate experiments for the community. And so that's why we ask master level, plus 3 years in terms of professional experience. And also, we don't have so many European opportunities. to fly. Typically, we have one, maximum two ESA astronaut opportunity launched to the space station at the moment. You know, all the astronauts, they have to do 2 flights. So that it is really a good investment to have some astronauts. So for instance, we have announced that we will have some flight of Thomas Pesquet very soon. So that's next month. We will have Samantha Cristoforetti. She will return to space station, and that will be their second flight. And after they have done these 2 flights, so they could leave the ground for new comers astronauts to fly to the space station. And in the time scale, that's for ISS. In the time scale for the moon, there could be opportunities for ESA astronauts in the time scale 2026, 2027, where you could have 1 astronaut joining our Orion crew to stay around the moon for 10 days. But it's likely that those, we have the current astronauts, they are top candidates for this work, but after they have done that, the next generation can go in. Yes. Oh, Nancy is with us now.
Yes.
Okay, so Nancy, we had a great presentation from Julien on EMATA. You want to? Okay, so he has presented the different pillars of the academy, the personnel, and so on. And okay, also. After we do that, we had planned to do a special chill ice event. That's what we do right after that. He did the presentation, but because he didn't, okay, we thought that we give you a second chance now to do a chill ice event. So to announce the astronauts. Yeah. Now that you're here, that's great, Charles. Okay, so Nancy, so you are going to apply as well. Oh.
That's a good question. I don't know yet.
Okay, but either you apply or you will train the candidates. Yeah.
I will train the candidates because I did apply in 2008 and I know exactly what the profile is that people are looking for. I survived 2 rounds. And I can assure you the competition is really, really tough. So I'm convinced that the potential here in the group is high enough so that some of you will make it until the final rounds. But let's say that, well, when I applied, I was in my 30s. Now I'm on the age limit. And you need to be on top of your career and on the top of your physical and mental capacities. It's just like a pilot, a professional pilot. And I'm hesitating to apply. Why? Because I think for myself, I peaked during my 30s. And to become even better than that, now, 10 years later, I think it's not realistic. That's the reason that I think I'm not going to apply for me now, personally. But knowing this, I'm really, really very enthusiastic to train all of you, to give all my experience and knowledge to get you on the level you should have to get it until the final rounds. So,
okay, so that could be part of one of the early pilot training of EMATA, a session with Nancy, sharing some hints, some of your experience. To prepare yourself to apply for the ESA astronaut call. I think that we should try to organize that maybe after we release this, after we have the call for itself. And we are planning an event on the 17th of April in collaboration with the Leiden Innovation Center in the area called the Field, which is near the Leiden train station. So we'll have a astronaut training session with Chill Ice colleagues. Okay, Mark has just joined us. Chill Ice, and then Mark appears on screen. That's good. We'll have also, we will bring some equipment there. And so we could also use that as an opportunity for a series of events, but one of them could be really a briefing to some of the candidates that we have for the ESA call for astronaut. That would be useful. So before the end of May with Nancy. Yeah, so
it should be a kind of personal coaching. So, you know, it's really very personal, and yeah, I can take the role of a coach.
Yeah. Also, so yes, we could organize that with a group. So now we have back with us Mark and Charlotte, and as we have mentioned, we had a very interesting presentation from Mark. He was on the shuttle between the moon and here, from what I've heard, because there was a lot of rocket sound during your presentation. But now we have also shown some of the video with the astronauts, and we give you the floor also to indicate what is the status with the chill ice astronaut and with the presence of Charlotte here in the Moon Mars workshop, and Mark still in his lava tube. So the floor is yours, chill ice. Thank you.
So we're just quickly gonna share the screen with you all. Yeah. So that's the other one.
Which one? Or I share screen as is?
Yeah, just share screen. And then go to the video. Oh, I need to open it here.
Present.
Downloads.
Oh, nice.
Pause. Intro video. Yes. And then pause it a sec. Yeah. So they can hear me now? You have the volume on. Hi everyone, you can hear me? Done? Hi. Okay, so hi everyone, good afternoon. As Bernard already said, we already gave a presentation about Chilice, but I heard there were some malfunctions with the introducing of the analog astronauts. So hereby I would really like to share the video with you all of our analog astronauts, and they can introduce themselves to this mission the best way. So here we go. So
it doesn't work.
Oh, I can't hear it. Have you? Okay. One sec, guys. I'm just gonna try one thing quickly. No, they couldn't hear it. They said no sound. So I think there is something with your Zoom settings. But let's check 1 second. Okay. Speaker, same as this one. Okay, let's try again, guys. Where's your video? Okay, let's open it. You should hear the sound now. My apologies for the technical malfunction.
What was the one you were thinking to do?
Yeah. Okay. Give us 5 minutes. I will do it from my own laptop. Yeah, of course. Yeah. Sabrina will make it public as well on the chat.
You have removed it. Maybe this.
Yeah, but I will just log in from my laptop and do it on my Instagram.
This is
And share the audio card on share.
primary function of this Human Mars Earth Space and Innovation Workshop today 3 on astronaut basis and the simulation. So I want really to thank you all for very interesting, intense presentations. We had a lot of material, a lot of research presented. So, you know, astronauts, that's very exciting, but even more research like you have shown we want to do. So thanks for all of you for your participation. Thanks for Kevin. So he was sharing a session. How many sessions did you share before, Kevin?
That's the first.
First time that Kevin was sharing.
A lot to learn.
Yeah, so great. He's learning about controlling the time of all the speakers and all this. In terms of training. Thanks for all of you who participated in person and also remotely from wherever you are. I think it was a beautiful session. So we have a broadcast on. So yes, all of you on Earth, Moon, and beyond. If you are on the YouTube channels, we salute you. And so we are. So we have now going into splinter work, where we are going to discuss some of the plans for preparing some of our next campaign. We do also some simulation and some work with the instrument, as we have described yesterday. But in terms of the plenary session, I think we are covered. We will try to broadcast again the Chilice video, and we leave this channel open for you. For discussion, if you want to use it to discuss with some of the other colleagues. Yeah? So I want to thank also the Innovation Center, Fabian, for hosting us today. So tomorrow we have a dedicated session on so-called Earth, Moon, Mars, and Society. We start again at 10 o'clock, so Leiden, Amsterdam time. And there will be some very interesting talks about our Earth on Mars initiatives in the last 10 years, but also the Moon Gallery team. And we will also inaugurate the Moon Gallery, the Bridge new exhibition that is installed here in the Leiden Innovation Center. So see you tomorrow morning. And the platform is still open for you if you want to continue to interact. And so Kevin is still there as our master of ceremony to manage this working session. So thank you very much. All the best. Aloha.
So thanks, Bernard, for everything. I guess definitely for organizing the workshop. We wouldn't have without him. So yeah, I think next Charlotte will. I think she's hoping to stream the video introducing the new Chilice analog astronaut. So if you hang on for a few minutes, hopefully we'll be able to show you that. So.
Yes, we have also Mark from the depths of his lava tube also available, and I think that you can also ask him a question. And we have various other members of the Chilice team with us. This is one of the news of today, the release of the name of the crew that will be part of the Human Mars Iceland Chilice campaign.
Yeah. Oh, it's connected. We have to figure out how to play it through the laptop. Wait, what is it? With this laptop we're sharing as a guest as well. That's the thing I shared from Hannah's, which isn't down as a host or anything. So yeah, yeah. But on this laptop, I shared on the other one, and for some reason it still wouldn't work. So oh, she's here now. Yeah, I have it here. It's just not on the stream. So that's what I did. Oh, so can you hear us? No. She's have to cut now. Oh yeah. Sorry, our other laptop is after cutting out, so I'll just give Charlotte the floor and hopefully it'll work.
Okay, so it's just some things. Okay, I will share the screen with you all. Let's start this video. Kevin, can you give a signal that you can hear it? Kevin, you're muted.
Say it again, sorry, we can't really hear you. Can you hear us? Which one is this?
Hi, could you hear the video?
Can you hear us?
Yes, Roxana or anybody else? Or Mark, could you hear the video?
No.
No? Okay, let's stop the share. Okay, I have it.
Oh, she got it now, I think.
Yes. Okay, last try then, and otherwise we will share the video on the social media accounts. Okay.
Can't hear anything. So I'm not hosting. Yeah, sorry, we still can't hear anything.
Unfortunately, but now we will just share it with our newsletter. As we share it with social media, I think there's something going on with Zoom that it doesn't allow the sound of the camera, or normally it does.
Bernard, it still wouldn't play. Charlotte, Bernard was wondering, are you going to share the link in the chat or just through social media?
We will share it via social media, via the regular Euromon Wars channels.
Okay.
As well as Facebook chat, and we will make an official announcement of our analog astronauts. Also, Susan Christiane is one of our analog astronauts, and she is here. So maybe she can just quickly introduce herself.
Brilliant, yeah.
Great, thank you.
Perfect. Yeah.
Yes, hi everyone. Nice to meet you all here. Yes, I'm really excited to be part of the Chill Ice mission. I'm an analog astronaut as a backup. And yeah, I live in Iceland. I was born in the Netherlands, and I have a background in industrial design with a special focus on creating resilient products and life support systems for extreme environments and challenging conditions. And yeah, currently I work as a business development manager and a marketing director for the National Technology Transfer Office in Iceland called EMMESI. And yeah, that's a short introduction, I think.
Thanks very much. It's great to, I guess, meet you, and hopefully soon as well we'll get to meet the rest of the Chill Ice astronauts. So thanks for coming.
Looking forward to meet you.
I think Mark is going to have another go at the video, hopefully.
Just gonna give another try.
Hi, I'm Sabrina Kerber, and I'm the commander for the Chill Ice lunar mission. I'm a space architect and analog astronaut from Austria, and I'm currently working as a drone operator in the Netherlands. In my free time, I enjoy any outdoor activity, such as hiking or sailing, and of course, having a coffee in the sun.
Hi all, my name is Anne-Lotte Weert. I will be the mission scientist for the Chill Ice Luna mission, and I'm a geologist and geochemist from the Netherlands with a passion for planetary science. And in my spare time, I really enjoy to do rock climbing.
Hi, my name is Agnieszka Albertowska, and I am the engineer in the Chill Ice mission. I am a student of computer science from Poland. I especially enjoy watching superhero movies.
Hello, I'm Eleanor Polly. I'm Swiss. I'm a PhD student in materials and metallurgy at the University of Cambridge in the UK. I will be the commander for the Chill Ice mission coming in May 2021. Fun fact, I like kiwis with the skin on, and I'm a handball player and triathlete.
Hi everyone, I'm David Smith. I'm from Glasgow in Scotland, and I'm an analog astronaut for the Chill Ice mission. So I'm a PhD student studying at University College London, where I'm working with the European Space Agency to develop machine learning tools for planetary science and astronomy missions. I'm super interested in human space exploration, and I'm really excited to contribute to this area by taking part in this simulation mission. So a fun fact about myself is I once sailed across the Atlantic in a 600 BC replica wooden ship. Okay, thanks very much, and I look forward to getting on with the mission.
Hello guys, my name is Gustavo Jamancalino, I'm from Peru, and in this mission I am an analog astronaut. Also, I am a metallurgical engineer and master student in space resources at Colorado School of Mines. In my free time, I really enjoy practice astrophotography and watching animes.
Hi there, my name is Willem Suter, and I'm the crew commander backup for the Chill Ice mission in Iceland.
I'm a mechanical engineering student from Switzerland. My favorite hobby is ski alpinism.
Hi, my name is Dr. Benjamin Potier. I will act as a backup analog astronaut for the CHILICE mission. I'm a professional explorer and a fellow international of the Explorers Club, as well as an expert for the Human Spaceflight Committee of the International Astronautical Federation.
Hi, I'm Suzanne Christianen and I'm an analog astronaut for the CHILICE mission. I live in Iceland and I was born in the Netherlands, and I have a background in industrial design with a special focus on developing resilient products and life support systems for extreme environments and challenging conditions. I work as a business development manager and a CMO for the National Technology Transfer Office in Iceland called EMME, and I've been working within the ESA Technology Transfer Network with the mission to transform inventions and technologies into sustainable solutions for society.
Brilliant. Thanks, Mark, for getting it working. It was great to actually to finally hear the video in full.
Excellent. That's what we need astronauts to fix problems. Thanks a lot for coming in and making it. Yes. So now we have completed our program. So you can still use the Zoom platform if you want to interact further with each other.
Okay. If anything has anything they want to add or say, feel free.
Thank you for all the talks. It was very nice to hear you all and see all the super projects that are on, and future projects that will be. So thank you. I really enjoyed the last couple of days and really can't wait to see you all one day in person. That would be nice.
Thank you, everyone. Thank you. Bye-bye.
Thank you very much.
Okay, a little comment now that we have concluded the session. We have a kind of a partner event which has started now. It's so-called the GALIX conference. So you are welcome to join in, and we will speak at the tomorrow session of GALIX together with Roxana and with Agatha. We'll have a 30-minute slot. So if you want to follow the GALIX link, at the moment there is Adriano Autino, the president of the Space Renaissance International, speaking, but there are a few quite famous speakers there. So you are welcome to join in. Maybe we will put the link of the GALIX on the chat now.
I'll get the link now and I'll put it in. Okay.